Good morning, sirs, ladies and gentlemen. I would like to welcome you during the third day of the conference. And today, from the morning, we will touch the panel number 3 also, which we started yesterday. The name of the panel is Air Pollution and Health. And the moderator for this particular panel will be Professor Georgi Gajev. And also, sir, I will ask you later on for a short introduction. And instead of the program, we have still one presentation recorded remaining from the last day. So, sir, after your short introduction, we will start with the remaining presentation, and then we will start with the panel number 3. Okay.
Good morning to everyone. Today we will continue the air pollution and health session with my presentation. We'll start with session with the presentation about the evaluation of the effect of national emission reduction strategies, and we'll finish with presentation about the impact of regulatory measures on pollution concentration. In addition, we will present, it will be presented the results about dependencies of ultraviolet radiation, indoor air quality in school premises, utilization perspective of industrial biomass residue, and several presentations about air quality modeling and forecasting.
Thank you very much, sir. So if we can start with the presentation of Professor Yavor Chapanov, please.
Temperature variations in Bulgaria region since 1936. My name is Yavor Chapanov from Climate, Atmosphere and Water Research Institute. The objective of this presentation is examination of common climatic and solar cycles in Bulgaria region. Use data consists of total solar gas, air temperature, and few components of wind. At service, used methods of analysis are partial layer approximation, where the coefficients of trigonometric functions are determined by method of least squares and fast Fourier transform. The obtained results common climatic and solar cycles in 16 low frequency bands. This is map of Bulgaria region, where is east part of Bulgaria and cover this rectangle with coordinates 42 to 44 north latitude and 27 to 88 east degrees east longitude. This component is Next is the component of wind. Also, wind values are negative. That means that the direction of this component is from north to south. And the next graph in blue color is the wind speed determined from these two components. The mean value of wind speed is about 2 meters, and it reaches more than 6 meters. The time series spectra are calculated by classical score, and what is really shaker about this spectra? You can take component has different time series spectra, so it is due to different sources of their excitation. And velocity also have common set of peaks, spectral peaks. So in the next investigations, I use only velocity time series because it reflects common width and few components of the wind. Temperature, by definition, should have common spectral peaks with the research. Two common Hydrocarbons and cleaning cycles. First graph points common variations of velocity of wind and temperature with periods 90 to 80, 108 years. We have very close common variations. This is without total solar invariance comparison because it comparison with these curves is only partial correlation with total solar invariance. And very good agreement exists about the capital variations total solar invariance in red color, temperature in green color, and velocity of the liquid in blue color. The value of the periods of this the color variations are between 22, 25, 36, 45, and 60 to 90 years. This is a relatively good agreement. That means that total solar invariance drive almost all decadal climatic variations. And the altitude of long-term wind and velocity vary between 5 and 40 centimeters per second, where the wave effect is up to 1 meter per second. The temperature amplitudes vary between 8 tenths to 6 degrees in high frequency bands. And their possible total effect may reach 30 degrees. These bands cover several cycles of solar activity. Solar magnetic cycle with 20-year period, 45-year cycles of north-south solar asymmetry, Blazeberg cycles between 70 and 120 years, and 178.7 year planetary period of solar cycle. Next slide shows common decadal cycles whose periods are below 22 years. We have relatively good agreement between solar and climatic cycles. phase parallels oscillation with periods between 16 and 18 years for first half of time series. It is antiphase between wind velocity and total solar irradiance, and also deviations that rise between climatic indices and total solar irradiance for half a century in the beginning of the last century. Here, other oscillations have good agreement, so it's possible to conclude that periodicity goes to 11-year solar activity the climate variations are driven by total solar irradiance variations. And common certificable cycles consist of oscillation between 5 and 9 years. This is 4 frequency bands, and in these bands we have a very good agreement between the phases between solar and climate variations, relatively good about amplitude variations, in this case 9-year oscillations, and amplitude of wind velocity from these bands vary between 1 and 13 centimeters per second, while the amplitudes of temperature are between 1 and 5 degrees, and the total amplitudes of wind velocity is up to 30 centimeters per second. About the temperature is up to 1.5 degrees Celsius. About the conclusion, the climatic conditions that Mexico's near Bulgaria strongly depend on solar activity cycles and their harmonics. The wind velocity and air temperature have common oscillation with total solar irradiance in 16 narrow frequency bands whose periodicity are centennial, decadal, and interannual. The models of periodical oscillation of climatic indices based on these common frequency bands may help to create long-term forecasts in this century. Thank you for your attention.
The first presenter of the session from tomorrow, from today, it will be given Dr. Evelina Georgieva.
Good morning. Do you hear me clear?
Yes.
Can I start?
Yes.
Okay. I'm going to share my presentation. Could you see it?
Yes.
I can hear. Did you see the presentation?
Yes.
Is it on full screen?
No.
Okay, just a moment. Now?
Yes.
Okay. Good morning, everyone. My name is Evelina Georgieva. I'm assistant professor at the National Institute of Geophysics, Geodesy, and Geography, Bulgarian Academy of Sciences. I will present evaluation of the effect of the national emission reduction strategies for the years from 2020 to 2029 and after 2030 on the sulfur and nitrogen wet and dry depositions on the territory of Bulgaria. This is the content of the talk. First, a short introduction, some words about the methods that we use for. I will explain about the emission scenarios, and we'll show the results from the numerical experiments about the nitrogen and sulfur deposition, together with the normalized mean bias calculated. Finally, some conclusions and acknowledgement. The atmospheric composition is formed by some processes like dry and wet deposition, horizontal and vertical advection and diffusion, emission processes, chemical transformation, aerosol processes, etc. All these processes interact with each other and determine the composition of the atmosphere in different scales. Complying with the Europe Directive from 2060 to 84, Bulgaria developed national emission reduction strategies for 2020 to 2029 and after 2030. Evaluation of the effect of these strategies on the sulfur and nitrogen wet and dry deposition for the territory of Bulgaria is our objective of the study. The main goal is to make a comparison between nitrogen and sulfur deposition simulated with different emission scenarios with and without taking measures. And these results are compared with the reference period, which is the period for 2005 with emissions for 2005 in Bulgaria. This kind of comparison made possible to evaluate the effect of the national emission reduction strategies, in this case for nitrogen and sulfur deposition. These tasks are performed by air quality modeling system. In our study, we use the USEPA Models 3 system, which consists 3 models, one meteorological model WRF, emission model SMOK, and atmospheric composition model CMAC. The simulated period is 8 years, from 2008 to 2040. The meteorological data is from NCEP global analysis data with 1 by 1 degree resolution. Also, the model's nesting capabilities are applied for downscale the simulation to 9 kilometers for the territory of Bulgaria. And this is the picture of the nested domains. And here is Bulgaria with 9 by 1 kilometer horizontal grid resolution. According to the Europe regulation, every member state have to report the set of emission projection scenarios that fall into the following categories. Projection scenarios with existing measures, it is called WEM, and means projection of the anthropogenic greenhouse gases or air pollutant emissions by sources that encompass the effect of currently implemented or adopted policies and measures. The second, projections scenarios with additional measures, it is called WAM, and means projections of anthropogenic greenhouse gases or air pollutant emissions by sources that encompass the effect of policies and measures which have been adopted and implemented, as well as planned policies that are judged to have a realistic change to be adopted and implemented in the future. In this work, 5 emission scenarios are considered for 2 different periods, the period 1 from 2020 to 2029 and after 2030, with existing and with additional measures, WEM and WAM, and the results are compared with the reference period 2005. Here should be clarified that only the Bulgarian emissions for the above period have been modified according to the forecast scenarios. Here are our 5 scenarios. Parallel calculations were performed for each of them. The first one is emissions for the reference period for 2005 for Bulgaria. 2 and 3 scenarios are emissions for 2020 to 2029 projected by existing and additional measures, WEM and WAM. And 4 and 5 emission projected after 2030 with existing and additional measures. As I said, the focus is about dry and wet deposition, modeled by the CMAC model. Here I put the deposition contains of nitrogen and sulfur. The output from the CMAC about the deposition is with 1 hour frequency. So we sum up the hourly values of the nitrogen and sulfur components for every day of the simulation, pending the daily deposition values. For comparison of the scenarios, we use the normalized mean bias, all the scenarios I will be presenting the next slide separately for the sulfur and nitrogen components, wet and dry components, also for total deposition, and comparison with the difference with the reference period. The last two slides, the normalized mean bias, which is also calculated. So here is the results from nitrogen deposition for different scenarios. Clearly, we can say that the results from all scenarios have a difference with the reduction tendency according to the reference period. It is better displayed for the plot of the nitrogen wet deposition, where we can see that the values for the some areas are smaller than those of the reference period. Also can say that the scenarios 2030 show the better results for the whole territory of the country. This is probably due to the emission configuration and the precipitation distribution. For the dry and total deposition, for the dry and total nitrogen deposition also has a reduction from the WEM and WAM scenarios according to the reference period. But here we cannot say which one of the scenarios working better. The next plot is about the sulfur deposition. Here, the effect of the emission reduction on dry deposition are best expressed, and the difference with the reference period are obvious. For the wet deposition, for the wet deposition, all the scenarios show better results according to the reference period, and for the total also shows that the scenarios of reduction of emissions lead to decrease the sulfur deposition. For all of the results, we can say that more stringent measures lead to more effective results, where in this study is about the WAM scenarios. The better result shows the WAM 2030 scenario compare with the reference period and also compare with all other scenarios. All these statements are clearly confirmed by the following plots, the next two slides, so where the normalized mean bias are calculated. As I mentioned, for comparison, we use the normalized mean bias. And according to these results, we can say not only that the measures of reduction of emissions worked or not, but also to see which one of the scenarios gives better results. Here I should say that for both nitrogen and sulfur, the color scale is to 0. So all the biases are with negative sign. That suggests that all the scenarios have smaller deposition compared with the reference period and emissions for 2005. All the measures shows positive effect of reduction of emissions and lead to reduction of deposition component, wet and dry, and total deposition. Here for the nitrogen dry deposition, we can see about 10 to 50% reduction over the whole domain and about 20% for some areas in the southern part of the country. The WAM scenarios show bigger reduction for both selected periods, but the WAM 2030 is clearly manifested. For the wet deposition, the reduction over the whole territory is about 10% and 50% for some areas. Here again, the WAM 2030 show bigger effect and the reduction reached to 20% for some spots. For the total deposition, it is for the previous assumption, about 50% reduction of deposition for all country and better results for the WAM scenarios. The biases from the sulfur deposition, again, all the biases are with negative sign. Here, the percent of reduction is very well expressed and show fruitful results of taking measures. For the dry deposition, the reduction reached 16%, almost over the whole territory of the country, and for all scenarios. On the plots of the wet deposition, we also can see the reduction of 30% for the whole domain and about 40% in some areas in the southern part. The result shows that the WAM scenarios for the both periods lead to bigger reduction compared with the WAM scenarios. And here again, the WAM 2030 is with bigger effect. The sulfur total deposition show reduction of about 60% in the southern Bulgaria and from 20 to 50% over the rest part of the country. And now I'm going to conclusions. The numerical experiments about nitrogen and sulfur depositions for different scenarios and compare with the results from the reference period shows that the results from the all scenarios has a difference with reduction tendency and show better results in comparison with the reference period 2005. The sulfur and nitrogen total deposition also has a reduction of the WAM and WAM scenarios in comparison with the reference period. For all the results, the taking measures lead to more effective results, where in this study, this is about the WAM scenarios. The best result shows WAM 2030 scenario compared with the reference period and also compared with other scenarios. The normalized mean bias is used for comparison the scenarios, and according to these biases, we can conclude that the measures for reduction of emissions worked, and to determine the better scenarios. For both nitrogen and sulfur, all the scenarios have smaller deposition compared with the reference period. All the measures shows positive effect about reduction of emissions and lead to reduction of deposition component and the total deposition. For nitrogen deposition, the reduction is about 15% over the whole domain and about 20% for some areas in the country. The bigger reductions is achieved by the WAM scenarios for both selected periods, but the WAM 2030 is the most clearly expressed. For the sulfur deposition, the reduction reached 16% almost over the whole country territory, and for all scenarios, the result shows that the WAM scenarios lead to bigger deposition reduction according to WAM, and again, the WAM 2030 is with bigger effect. In the end, I want to acknowledge these two projects for the financial support: the National Science Program, Environmental Protection and Reduction of Risks of Adverse Events and Natural Disasters, and the National Geoinformation Center, subject of the National Roadmap of Scientific Infrastructure. And also thanks to the USEPA, USNCEP, and the TNO for providing us free of charge data, software, and high resolution emission, European anthropogenic emission inventory. And also thanks to you for your attention. Sorry, we cannot hear anything.
presenter? Enable editing is not. В горната част има Enable editing и след това slideshow. Thank you very much. Good morning, everyone. My name is I'm professor in toxicology in National Center of Public Health and Analysis. Professor Gadget, dear organizers, thank you very much for the opportunity to share our results from this study. Let's start with a few words. Next slide, please. Who we are? We are National Center for Public Health and Analysis with more than 100 years history in topic of hygiene, public health protection, and we are institute. Now the institute is successor of the Center of Hygiene, Medical Ecology and Nutrition. And it is scientific institute within the national healthcare system. Next slide, please. The main topics of our work is public health and health risk, environmental, occupational, and risk related with nutrition, health promotion and diseases prevention, laboratory and analytical activities, mental health and addiction prevention, information provision of healthcare management, training of PhD students, postdocs, and etc. Next slide. Before, previous, please. Previous, please. Okay. Introduction. Thank you very much. According to the Health World Organization, there is no safe level of fine dust particles, particle matters. As we all know, the air quality is increasing attention among both academia and physician medical doctors due to growing the evidence of its impact on human health. The World Health Organization estimates that around 7 million premature deaths occur worldwide due to long-term exposure of poor air quality each year, both indoors and outdoors. The focus of air quality regulation has historically been protected in human health against against the adverse effect of the release of air pollution into the environment. The external environment by setting limit values of air pollution typical for urban areas and workplace environment, setting the threshold limit in the workplace air. In fact, nowadays, in Europe, there is no limit values for indoor air quality for particle matters and chemical pollution. There are many activities such establishment of health standards, guideline documents, mainly from WHO, and Environmental Protection Agency in the United States, and a recommendation, for example, Germany has such kind of recommendation which can be used to compare the results of this recommendation. For the negative health effect, it's related with particle PM exposure is extremely important to know what exactly toxic substances are incorporated in them. Therefore, the chemical characterization of composition particle meters provides very important information on the degree of expiration and health for the health risk assessment. Next slide, please. Based on this, we aim our study, and the present study aims to characterize the air quality in the classroom in real time in autumn winter. This is the period when values of the measured air quality indicators indicators above the limit values are observed. The present study has been carried out within the framework of the National Scientific Program Environmental Protection and Reduction of Risk of Adverse Event and Natural Disaster, approved by the Council of Ministers and supported by Ministry of Education and Science of Bulgaria. Next slide, please. The design of our study is based on the air quality data provided by the Bulgarian Executive Environmental Agency for the city of Sofia over the period of 10 years, and then they show annual amplitudes with pronounced elevated values during the autumn and winter season. Object of our study is a school, the investigative school are selected in area of the city of Sofia, where the high level of average daily PM10 values were registered. This is on the map with the red, it's marked school, which is very close in the area. And on the map on the right bottom, this map shows the automatic system station. The automatic measurement system they measured in real time from Bulgarian Executive Environmental Agency. You can see there is in Sofia 6 of them, and 3 of them every winter season show very high, not very high, show high level of PM10 concentration. One of them is Hippodrome area. We decide our subject of investigation to be children in early school age, from first to fourth degree, 7 to 11 years old. They was consist with the higher sensitivity of the children's body to impact of environmental risk factors. So this is how to say a susceptibility group. Next slide, please. Few words for methods we study. The sampling of Vox and measurement of PM10, PM2.5 carbon monoxide and carbon dioxide were performed in the period from 6th of December till 10th of December of 2021 in 2 classrooms and teacher room. Also, outside of the school, in the school yard. The duration of sampling period is 5 full days and covered 2 school shifts from 4 to 6 school hours and intervals between them. This was very important because in the intervals, you know, children, the activity is very high. And the results for example, for carbon dioxide is increased in this period between the school hours. To determine the peak values during the measurement period in each room, the dynamic of air pollution was monitored daily by performing 6-fold 3-minute measurement at room moments, random moments for PM10, PM2.5, and carbon monoxide and carbon dioxide. The measurements were performed with a portable monitoring device, EVM3, with laser photometer for measurement dust fraction PM10 and PM2.5 in real time. With this device, automatic gas analyzer, carbon monoxide and carbon dioxide was measured. The sampling was performed with passive sampling devices for benzene, toluene, ethylbenzene, xylene, and aldehydes. Benzene, toluene, ethylbenzene, and xylenes were measured by gas chromatography with mass spectrometric analysis, and formaldehyde and acetaldehyde were measured by HPLC chromatography. Next slide, please. On this slide, you can see some picture from measurement we conducted. The position of passive samplers, devices, blue one, on the top of the picture. On the bottom of the picture is a Christmas tree. The position of passive samplers was with complies with requirements of ISO standards. The position of in the premises is high, about 1.5 meters above the floor, and at the distance of more than 1 meter from windows or doors. For outdoors measurement, a height of about 2 meters above the ground. The samples was transported in laboratory and analyzed with appropriate analytical equipment. The school is very near to our institute, so maybe 5-10 minutes we need to transport the samples to laboratory. Next slide, please. Let's start with the results. On this table, you can see the results for particle methods. On the right of the table, you can see the data from automatic measurement system of Hypogruma point. In general, it's not possible to compare like that, but we show this data just for show you the trend of and relation between the results of in the classroom, indoor air and outdoor air. You can see in the schoolyard, for example, that the result is very close to the results from Hippodroma. Next slide, please. In this slide, it's shown the comparison of air pollution in the studied school premises with the pollutant of the atmospheric air outside. And figure A show PM10, figure B PM 2.5. You can see the red line is the data from Hippodroma station, and the same results showed also our yellow one in the schoolyard for PM10. The same tendency is also for 2.5 PM particle meters. Next slide, please. The next results on this slide is the result for measurement of carbon oxide and carbon monoxide and carbon dioxide. As we expect, in the blue one column, this is outside results from outside. They are higher because carbon oxide is related with road pollution from cars, etc. And for carbon dioxide, the highest value is in the classrooms because of maybe more activity of the children and different, not only activity, different more people on one premises and etc. Next slide, please. On this table, you can see the results for measurement concentration of benzene, toluene, orthometaparabenzylene, ethylbenzene, formaldehyde, and acetaldehyde. The results were calculated and compared based on the indoor-outdoor ratio, which is published in WHO guideline for indoor air quality. You can see that it's above 1 for every substances. Next slide, please. And this is the same result, but with figure expressed. You can see that in the both classrooms, especially for one of them, the formaldehyde concentration is high. We made a conclusion. I will show you later. Next slide, please. That is the conclusion. So the results of the study show that the level of pollutant with particle matters average over a period of 1 school week in the surveyed school premises are lower than those in the air outside. Average in the schoolyard for the same period. Monitoring of the dynamic of air pollution in the classroom by day, it was found that the concentration of dust in the premises are in most cases lower than concentration of air outside, but follow the same trend. Based on the results, we can conclude that the degree of the air pollutant in the classroom is directly dependent on air pollutant at the high values of air pollutant, high values of PM10 and PM 2.5 are reported in the classroom. The higher values of PM10 dust fraction in the premises in the same measurements are due to internal factors, secondary pollutant due to poorly clean surfaces, combined with great activities of occupation and on the premises. The average of concentration of carbon oxide in the studied school premises are lower than this measured in the schoolyard. And those of carbon dioxide in the premises are significantly higher than the measure outside of a period of 1 school week. Next slide. Higher level of carbon monoxide in the open area, most likely due to incomplete combustion of fuel by road. In the absence of other sources of indoor carbon dioxide emission, higher level are mainly associated with human metabolism and the number of occupation regardless of ventilation during the breaks. The high concentration of formaldehyde measured in the classroom are probably due to the use of glue and other materials during the practice activities and also from the furniture, because in the period of measurement on the one of the classroom, the children make some practical things with the glue. The measured average indoor benzene concentration shall not exceed the WHO recommendation indoor air value, which is 10 microgram per meter cubic. Of the aromatic hydrocarbons measurement indoors, the concentration of toluene are the highest. Concentration of benzene, toluene, ethylbenzene, and xylenes in all school premises are higher than in the schoolyard. This indoor-outdoor ratio is above 1. Next slide, please. Taking into account that the studied school is renovated and meets modern requirements, which means does not use its own heating, because in some area, some schools use their own heating in winter, mostly solid fuels, and do not use chalk. Still in same school, in the small settlement are used. It can be made the following recommendation. During the winter period, the ventilation should be more intensive. The windows of the classroom and the corridors should be open in order to ensure the movement of air masses. This will lower the concentration of carbon dioxide. After the school hours in 12 noon and in first shift and second shift 4 p.m. After sweeping the classroom, it will be good to wet clean the room. At the end of the day, to clean the dust on all furniture and seals in order to reduce contact of particle emitters. Next slide, please. What will be the next steps? As in the framework of the present study, we perform also sampling for the contact of polycyclic aromatic hydrocarbons, pHs. Most of them we know all that is cancerogen. We will process the data and include compare with other pollutants in this study. Performing measurement in the premises of the same school during the summer season Also, we will measure the indoor air of other schools near the long critical points of pollution with PM in Sofia during the winter and summer season. This is Nadezhda area and Pavlovo area. And also because we have a previous study on the same schools, we will compare with the results with the previous measurement. Next slide, please. This is my last slide. We would like to thank for the National Science Program, Environmental Protection and Reduction of Risk or of Adverse Events and Natural Disasters for the opportunity to present this, to carry it out and present this study. And also, I would like to thank you for your attention. Yeah. Outside, yes. No. Can you please give me some of my slides? Which compound you mean? Colleagues? Huh? Back, please. This here? You mean PMs? Okay. Can you please give us the conclusion? Okay. This means, yes, the conclusion number 5 is related with the no, CO is higher than in outside. In the school premises are lower than in the schoolyard. Yeah.
I'm sorry for the public because yeah. So the question is, according to the study results, CO in the school premises is more than one measured in the schoolyard.
Exactly.
And if
because
we can,
CO comes from the cars. And CO2 come from metabolized activities, etc. That is in the premises higher than outside.
okay.
And your question is if we make ventilation.
Right. If we do ventilation, actually, let the fresh air come inside.
We'll pollute and
right. And if you go next slide.
Okay. No. Conclusion.
Yeah.
This one. Open air. There is a technical mistake. Not R and A.
Okay.
Okay.
Good. Thank you.
Thank you. Thank you for the question.
Follow question.
We cannot hear you. Maybe in the chat box.
Sir, can you repeat the question one more time?
Yes, I have a question. Do you hear me?
Yes.
Sir, we can hear you and we can see you, but we cannot hear the question.
My connection is very bad. First, I would like to thanks to very nice presentation. Actually, my question is are two statements. First of all, such an investigation should be used as basis for policy for the indoor air quality treatment. It should be used for the authorities, local authorities. And that's why it should be popularized between these authorities. The second, because as was shown, some of the VOCs, the volatile organic compounds, the concentrations are relatively high. For example, the benzene was close to the WHO norms. It's right? And my second proposal is that more or less the indoor air pollution concentration is connected to the outdoor concentrations. It was already shown, and we have very long time series of high resolution estimation of the main air pollutants. You can ask, as you said, Professor Georgi Gajev sitting close to you, and this could be used as basis for further scientific cooperation. Thank you again.
Thank you very much for this comment. Are we, are out. Much for the comment.
Аз си канаве, нищо да не чувам.
Me now. Professor Chevenko, can you hear me?
Now the level of the sound is acceptable. Could you repeat the last sentence, please?
Of course. In fact, we are together with Professor Gajev in work package. Within this work package, the present study was carried out, and we are in collaboration. And you are totally right that the investigation and studies like this it must be basis for political decision and decision related with risk management. So, in fact, the idea of this national scientific program is this to show, to input scientific evidence for risk management.
Thank you.
Thank you. Thank you for the questions, comments.
Are there any other questions from the audience?
Please keep the mic closer to your mouths because the level of the sound is very, very low.
Okay, if there are no additional questions, we will take the break right now and we will be back again at 10:25. Thank you very much.
Georgi, can you hear me? Can you hear me, Georgi? Yeah, can you hear me? I don't hear anyone. I don't hear anything, just a moment. Now I can hear. Okay.
Dear colleagues, we'll continue with the recorded presentation of Dr. Rumiana Bozilova. It is investigation of dependence of ultraviolet radiation on the day.
Hello, dear colleagues. My name is Rumiana Bozilova, and in the next few minutes, I will introduce you a study for the dependence of ultraviolet. Hello, dear colleagues. My name is Rumiana Bozilova, and in the next few minutes, I will introduce you a study for the dependence of ultraviolet radiation on the day. Briefly, the highlights of this presentation. First, some facts about the UV radiation. Instruments and methods for obtaining information on the flux of ultraviolet radiation UVA and UVB in urban conditions. Measurements made not only of the radiation flux in a horizontal plane, but also in a plane perpendicular to the direction of the sun at the permissible time, allow us to assess the risk of sunburn on the skin in different positions of the human body. Study of the dependence of UVA and UVB on the zenith angle of the sun in the clear weather. Assessment of the influence of the main components responsible for the absorption of UV radiation: total ozone column, water column, aerosol optical depth. Comparison between the values obtained by vertical and sun target measurement and the expected theoretical dependence for UVA. Proposal for correction of the time for permissible stay under direct sunlight without danger to human skin. We all know that the small amount of UV radiation are beneficial for people and essential in production of vitamin D. UV radiation is also used to treat several diseases, including rickets, psoriasis, and eczema. Prolonged human exposure to solar UV radiation without precautions may result in acute and chronic health effects on skin, eye, and immune system. Sunburn and suntan are the best known acute effects of excessive UV radiation exposure. Chronic effects of UV radiation include two major public health problems: skin cancers and cataracts. That is why it is extremely important to monitor UV radiation reaching the Earth's surface and its impact on human health in order to prevent and reduce the risk of harm to humans. An assessment of the possibility of getting sunburn on human skin with a certain duration of sun exposure gives the index of biologically active ultraviolet radiation, so-called UV index. This index is related to the energy of UVB falling on a horizontally located unit area. The value of UV index at a given time and place depends mainly on the location of the sun in the sky and the state of the atmosphere. As sunlight passes throughout the atmosphere, all UVC and approximately 90% of UVB radiation are absorbed by ozone, water vapor, oxygen, and carbon dioxide. Organization of the measurements. We have selected 3 days for the study in which there are no clouds throughout the day and the weather is clear, namely the 8th, 12th and 13th of April 2022. In a half an hour, the values of UVA and UVB were measured in the vertical position of the matter and with the device directed towards the sun. The first value corresponds to the radiation flux in a horizontal plane and the second in plane perpendicular to the line between the instrument and the sun. Expect measurements of ultraviolet radiation. The values of the main factors responsible for absorption of UVA and UVB were measured, namely total ozone column, water column, aerosol optical depth. When pointing on sun photometer at the sun, the values of these 3 quantities are automatically adjusted for the instrument to their vertical values. Detailed description of the device which we use to study SUV and UVA.
SolarLight's UV Minder Model 3D UV intensity meter is capable of measuring both the UVA and UVB spectra. The UV meter shows the intensity of UVB, also called SUV or sunburning UV, and minimal erythemal doses per hour, which is the accepted clinical measure for sunburn potential. The UVA detector measures UV intensity in the range between 320 and 400 nanometers, displaying UVA radiance in milliwatts per square centimeter. We also offer the UV Minder Model 3D XP Xeroderma erythemal UV intensity meter for measuring very low UV intensity to 3 decimal places. The 3D meter is very user-friendly. The sensors are mounted on the meter itself, and its compact size and lightweight ensure total portability. Typical applications include SPF testing, cosmetics research, dermatology, environmental research, agricultural applications, and forestry.
Short introduction of the ozone monitor and sun photometer.
SolarLight's Model 540 sun photometer is a compact, handheld 5-channel multispectral instrument designed to measure direct solar irradiance at all selected wavelengths. It then uses this information to provide atmospheric properties, such as aerosol optical thickness and water vapor column. Standard wavelengths in nanometers to choose from include 340, 380, 440, 500, 675, 870, 936, and 1020. The unit features very high accuracy comparable to much larger and more expensive instruments. An optional GPS receiver is also available to facilitate field operation. Typical applications include weather stations, scientific and educational studies, pollution monitoring, photobiology, environmental monitoring, vicarious calibration, and irradiance-based calibration of imaging sensors.
Ozone absorbs some of the UV radiation that would otherwise reach the Earth's surface. Ozone levels vary over the year and even across the day. This figure shows the different variation in total ozone column during the 8th, 12th, and 13th of April 2022. The observed variations are insignificant, about 12%, and do not affect the dependence on the zenith angle of the sun. Another factor affecting the absorption of UV radiation is water column. The values of precipitable water column are relatively high on the 8th of April, probably due to rainfall the day before. On the 12th and 13th of April, the values are low throughout the day, especially on the 13th of April around noon. The last observed factor affecting the absorption is aerosol optical depth. The figure shows significant variations, especially on the 8th of April in the afternoon, when a partial cloud cover was observed. Measurements at these hours are performed at time when the sun is free of cloud cover. With aerosol optical depth variation between 0.1 and 0.5, the UV index varies from 10 to 8. However, most of the obtained aerosol optical depth values are about 0.2, which suggests that the effect of aerosols are insignificant on the absorption of UVB in the present study. This slide shows the dependence of UVA radiation flux on the cosine of the zenith angle of the sun according to the measurements. The dependence of UVA in the direction of the sun is close enough to the linear one, red colored symbols and line. The blue dotted line shows the theoretical dependence of UVA in the vertical direction, which turns out to be close to the measurement marked with the blue symbols. The same procedure is used for the UVB. The results show a parabolic dependence of UVB on the cosine of the zenith angle of the sun, and in the case of UVB measurements in the direction of the sun and vertical UVB. An interactive calculator has been developed on the website of the National Institute of Geophysics, Geodesy and Geography, which allows us to determine the time for a safe stay under the sun without harming us. The results here show the relationship between the UVB radiation measured in the vertical direction and the one measured in the sun direction. The conclusions presented by the figure are that in the morning and in the afternoon, the permissible time for stay decreases to 65–70% of what is calculated on the basis of vertical measurements. Additionally, at large zenith angles of the sun of the order of 65 degrees, significant areas of the skin of an upright person are exposed to direct radiation. At small zenith angles close to noon, the safe stay time for areas of skin oriented to the sun does not differ significantly from those recommended on the basis of the standard UV index. Here are some conclusions of the present investigation. In general, the results show that the dependence of the index of biologically active ultraviolet radiation is well described by the square of the cosine of the zenith angle of the sun. In cases where the risk of sunburn in areas of human skin oriented perpendicular to the sun is considered, the simplified dependence turns out to be incurred. The measurements made for the present study make it possible to offer an empirical coefficient for estimating the increased risk of burns in those areas of human skin that are oriented to the sun. As a result, a correction factor of the permissible time of safe stay in the sun has been proposed. And finally, I want to thank you for your attention.
With the presentation which will be given from Dr. Svetlina Petrova. It is here.
Yes, I'm here. Can you hear me?
Yes. Okay.
Shall I share my presentation? I'll try to. Do you see my presentation? Because I don't see it on the screen. Can you see it?
No.
Then I will ask the colleagues to do it for me if it's not a problem. Unfortunately, I cannot share the presentation. Could you please do it instead of me? I have provided it.
Yeah.
Thank you. Thank you, I can see it. Yeah. If you hear me clear, I will start now. Yes, thank you very much. So, good morning, dear colleagues. My name is Ileana Naidenova, and I'm going to present this presentation entitled Utilization Perspective of Industrial Biomass Residue on behalf of Associate Professor Svetlana Petrova, who could not manage to join today's meeting. Next slide, please. The content of the presentation involves several general topics, in particular introduction, objectives, explanation of the experimental conditions and the experimental setup, the methods used for biochar characterization, as well as some results and discussions and general conclusions. Next slide, please. First of all, I would like to give a short overview about the conversion technologies of biomass which are currently being used. If we consider the typical processes, the specific processes involved in biomass utilization, we can classify them into general groups. The first one, processes for biomass utilization, and involves processes such as pyrolysis, carbonization, combustion, gasification, liquefaction, or even hydrothermal treatment. The second group is mainly related to biochemical processing after biomass and is based on processes like alcoholic fermentation or anaerobic digestion. Of course, there are different variations of all these processes, which can be discussed in detail if it's necessary. However, we have decided to use carbonization technology because it refers to a process whereby biomass undergoes a thermochemical conversion in an inert atmosphere. The main goal was to produce high-quality charcoal, and which is very often called biochar. Why biochar? Because it's known for having numerous applications. For instance, as biofuel, it has been proven to have the advantages of being readily combustible, having low bulk density and high calorific value, as well as reduced PM emissions. Of course, there are well-known examples in the literature for quite a huge variety of applications of biochar. It can be used as a fertilizer, as catalyst with different applications, as well as for CO2 sequestration, as well as for the production of supercapacitors and many other products with a huge variety of applications. Next slide, please. Next slide. Thank you. The general objective of the present work was to investigate an utilization path for industrial biomass residue. And for that purpose, the following global tasks were drawn. First of all, we had to estimate the biochar yield obtained during carbonization of technically hydrolyzed lignin at atmospheric pressure conditions and at 3 different temperatures. The achieved biochar, the obtained biochar had to be thoroughly characterized, and for that purpose we decided to use several different well-known analytical techniques, most of which I will explain a bit later together with the general results. In addition to this, we had to propose possible biochar applications in view of the present European effort for circular economy and climate change preservation. Next slide, please. The work was inspired from the previous investigations carried out in the group of Technical University of Sofia, which in this specific preliminary studies, we have proven that the emissions of PM can be significantly reduced when biochar is burned instead of biomass. In addition to this, we have done a thorough experimental and theoretical study of biochar, which is derived from different types of agroforest residues. The chosen experimental conditions in this particular case study were as follows. The biomass residue was carbonized in electrically heated horizontal tube furnace. The experimental temperatures chosen for the experiment were gradually increased from 5 to 700 degrees Celsius. The experiment was carried out at atmospheric pressure and in inert atmosphere of nitrogen. The samples were left in the reaction zone, so the residence time of the samples in the reaction zone was about 1 hour. In a nitrogen flow, at constant nitrogen flow rate of 1 liter per minute. Most of the preliminary studies have been already published, and you can see the references at the end of the slides, at the bottom of the slides, I'm sorry. So could you please show the next slide? So the experimental setup which has been used is presented in the picture on the left-hand side. It has been developed in-house together with a group of the Portuguese Polytechnical University in Lisbon. Of course, in our case, we would like to suggest a biomass processing technology, and for this study, it is crucial to understand the characteristics of the biomass feedstock and the decomposition behavior in the given experimental conditions. So the reaction zone in this particular experimental approach is defined by the quartz tube, which is horizontally laid in the furnace itself. So with the help of thermoregulatory block, we can introduce isothermal, stable isothermal conditions in the reaction zone, where we settle the crucibles with the samples. And therein, as I already said, in inert atmosphere of nitrogen, the experiment is carried out. This apparatus was presented in 2019. Next slide, please. The lignin, which was provided to us, was obtained after high temperature diluted sulfuric acid hydrolysis of softwood and hardwood chips to sugars in industrial conditions. And because it's a residue, it appeared to be a residue of the industrial process, it is currently undergoing uncontrolled degradation at the territory of the plant, of the industrial plant. So therefore, we were requested to propose a suitable utilization technique and technology. You can see that the biochar is relatively good after the carbonization process at the 3 different temperatures. They achieved biochar together with the initial feedstock were chemically characterized using the set of the described analytical methods. So lignocellulosic analysis was performed merely for the lignin. The lignin and the biochar samples were analyzed through approximate, ultimate calorimetric analysis, as well as thermal analysis, ICP, and infrared spectroscopy, as well as beta analysis. Next slide, please. The chemical characteristics of the samples are summarized in the table on the screen, and it allows us to draw the following general conclusions. Increasing the carbonization temperature led to the following general effects. We have observed significant reduction of the content of volatile organic compounds in the biochar. As well, on the other hand, the fixed carbon content was considerably enlarged. And we have observed also some slight increase in the ash content. Concerning the elemental distribution, the general elemental, the elemental distribution generally in the organic part of the substances, the derived substances, we can see that the carbon content is increased, and on the other hand, the hydrogen and oxygen content is considerably reduced. And in addition to this, the hydrogen and, the nitrogen and sulfur content is considerably reduced for some samples even below the detection limit, which was quite an expected result. In addition to this, the high heating values of the biochar samples were also found to increase with about 25 and little higher percentage. Next slide, please. The thermal analysis in terms of thermogravimetry, differential thermal analysis, and differential scanning calorimetry is widely used to study biomass conversion processes, and not only biomass, of course. In this particular experiment, a simultaneous thermal analysis was carried out in dynamic heating mode conditions from room temperature to 1000 degrees Celsius at constant heating and airflow rates and static air environment. Generally, 3 different stages were observed in the thermogravimetric curves, for instance. It's quite clearly visible. So the first one, of course, envisages processes related to water vaporization and lasts for a very short temperature interval between room temperature and 200, for some samples 240 degrees Celsius. The devolatilization and dehydrolysis of some substances such as calcium hydroxide has been observed merely in lignin thermal degradation process. Due to the significant reduction of the volatiles content, this stage was overlapping with the biochar combustion in the samples of biochar. Next slide, please. So the biochar derived at higher temperatures showed its highest mass loss at higher temperatures, of course. For the biochar derived at 700 degrees Celsius, you can see that stage 2 and 3 basically finish at very high temperature at about 900 degrees Celsius in comparison to the lignin, which is about a little higher than 500 Celsius. In addition to this, the peaks at high temperatures were associated with the thermal decomposition of both thermodynamically stable species substances, namely lignin and polysaccharides. Next slide, please. So some of the global thermal characteristics and parameters are extracted in the table herein. The thermal analysis of lignin and its carbonized products show the presence of merely exothermic reactions. And the temperature of the DSC peaks coincided well with the appearance of the maximum mass loss rates. Next slide, please. In addition to this, Fourier transformed infrared spectroscopy was applied to study the distribution of the functional groups in the studied materials. The lignin spectrum is shown on the left-hand side, and biochar spectrum is shown on the right-hand side. The general conclusion that can be drawn in this case is that increasing the carbonization temperature reduces the peaks of, gradually reduces the peaks of some functional groups, and the most pronounced functional groups appearing at the high temperature biochar were those related to the existence of polycyclic aromatic structures and the related CC and CH bonds therein. Next slide, please. The results from the ICP analysis of the feedstock and the obtained biochar are summarized in the table herein. The analysis was performed by after pre-acid decomposition of the used materials, and the results are obtained in accordance with prescribed standards. So, as expected, I would say, as expected, besides the content of lead, alkalic metals, and the content of carbon and titanium, most of the other metal and non-metal substances were significantly concentrated with increasing the biochar temperature, which was expected on our opinion. Next slide, please. The last summary of the results I would like to share with you is the analysis which we have done in order to estimate the surface area and the pore size distribution. So the specific surface area was determined by low temperature nitrogen absorption. For that purpose, the samples were outcased prior to the analysis at temperature of 120 degrees Celsius for at least 16 hours in vacuum. So the nitrogen absorption-desorption isotherms were used to evaluate the following general parameters. First of all, the specific surface area. The specific surface area was obtained based on the wet equation, together with the total pore volume. And in addition to this, the micropore volume and the micropore surface were also considered, along with the mean diameter of the pores and external specific surface areas. In order to conclude, the higher carbonization temperature led to higher bed surface of the studied biochar and lower total volume and pore size distribution. It also shifted the pore distribution from meso to micropore size with increasing the temperature of the carbonization process. And for the biochar obtained at 600 and 700 degrees Celsius, we have observed narrow interval of pore radius variation, something like between 1 and 2 nanometers, which is equal to 15 or 20 to 20 angstroms, as much as I remember, which allows for proposing these materials for the selective absorption of specific molecules, which is very particular in this case. Next slide, please. So, if you allow me to conclude on the presentation, on the general results presented herein, increasing the carbonization temperature generally led to the following global effects: significant reduction of the content of volatile organic compounds, and increased fixed carbon content, together along with slightly increased ash content, the considerably reduced hydrogen and oxygen content, as well as nitrogen and sulfur content which was even below the detection limit, and increased higher heating values have suggested the possible biochar application as solid biofuel. The results obtained in the infrared spectroscopy and wet analysis have suggested other applications. For instance, the functional groups, as I said, were gradually lost or decreased due to the increased carbonization temperature. And we have observed merely polycyclic aromatic structures and high condensation rate in the biochar obtained at high temperatures. The proposed utilization technology for the lignin, specifically the carbonization at 600 and 700 degrees Celsius, produced biochar having the properties typical for the monomicroporous absorbents, which allows for selective absorption of specific molecules, and suggested us to propose its application as catalyst, which still has to be, of course, examined under specific conditions. Next slide, please. With this, I would like to thank you for your attention and to acknowledge the financial and technical support provided by the environmental program, our national science program, as well as I would like to stress on the tight collaboration which we have in an interdisciplinary research team involving experts from Technical University of Sofia and the University of Chemical Technology and Metallurgy in Sofia. So with this, I would like to thank all my colleagues for their huge contribution, and I'm ready to answer your questions in case there are some. Thank you.
Thank you, Professor Najmova. The questions will be at the end of the session.
Okay.
Now we'll continue with Dr. Angel Jambov. Due to Professor Stefan Sankowski has the technical connection problem, and we'll continue with Dr. Angel Jambov.
Okay, thank you. I trust that you can hear me clearly. Let me just share my screen. Okay, can you see my slide?
Yes, we see it.
Okay, great. Let me make it full screen. Okay, my name is Angel Jambov. I'm with the Medical University of Plovdiv, and together with colleagues from Sofia University, as well as the National Center of Public Health and Analysis, we carried out this pilot study looking at the association between daily concentrations of specific air pollutants and hospital admissions for asthma in Sofia. And this project was also funded under the National Science Program, Environmental Protection and Reduction of Risks of Adverse Events and Natural Disasters. So I'm presenting a health perspective on the issue of air pollution. And surprisingly, until this day, there have been very scarce research on short-term effects of air pollution that employ advanced statistical modeling approaches. So in this regard, ours adds to the literature, even though the foreign literature is quite convincing on the association between asthma and air pollution. So we've decided to focus on asthma, even though we plan to expand the analysis with additional health outcomes, because it is a disease that is well known to be associated with air pollution, and also exerts a heavy toll on Bulgarian population. There are more than 400,000 registered asthmatics in Bulgaria, and these are arguably conservative statistics, as health statistics sometimes underestimate the true prevalence of a disease. So people with asthma are also more susceptible to exacerbation, so to worsening of their condition as a result of exposure to air pollution on high pollution days. And a recent report on the health effects of air pollution in Bulgaria estimating that anywhere between 10 to 20% of respiratory mortality from respiratory disease in the country can actually be attributed to air pollution, mostly to fine particles. So there has been very convincing evidence from both experimental studies with test animals and as well as epidemiological studies in large population groups linking air pollutants to adverse changes to the respiratory system. So remodeling of the airways, thickening of the air walls through immune and other mechanisms, which ultimately lead to bronchospasms and may both precipitate the onset of a disease like asthma and also exacerbation of this disease in people who already have it. Recent meta-analysis that synthesize information from multiple primary empirical studies actually estimated that the pooled risk across the entire body of evidence of an association between asthma and different air pollutants was anywhere between 1 to 5%. And this refers to short-term effects. So the risk of asthma or unit increase in air pollution on high pollution days. In Bulgaria, as I already mentioned, the body of evidence is somewhat limited. And in order for us to carry out health impact assessments, burden of disease assessments, and basically tell stakeholders and authorities how changing air quality would improve public health, we need more robust estimates of the risk associated with air pollution. So that we can calculate the attributable morbidity or incidence of this disease. These are the results of one of the recent meta-analyses I mentioned. So you can see that on the same day, pollution as the admissions for asthma, different pollutants are associated with anywhere between 0.7 to 1%. Actually 3% for associated with carbon monoxide, increased risk of asthma. And the lagged exposure, so the day preceding hospital admissions, is even stronger associated with some of the risks. This is an overview of studies that have so far been carried out in the country on short-term associations between asthma and other respiratory disease and air pollution. So there were recently these two studies on COPD, which is chronic obstructive pulmonary disease. So they followed up patients over a year. One study focused exclusively on patients with COPD from Pleven. Another one was a multi-center study from based in different cities. And what they found was that on high pollution days, certain pollutants, specifically PM10, were associated with, were positively correlated with the admissions for exacerbation of COPD. However, these studies didn't employ advanced statistical approaches, so they simply estimated more simplistic correlations rather than a proper time series analysis. A more recent study by Simichiev and colleagues looked at daily and lagged concentrations of air pollutants in relation with different diseases. Their statistical approach was superior to that of earlier studies, and they also found that various adverse health outcomes were more likely to be registered. So people are more likely to be hospitalized or call for an ambulance on high pollution days. The aim of the present study, as I mentioned, was to investigate the short-term effects of air pollution on hospital admissions for asthma in Sofia. We focused on Sofia first because of its large population, which provided sufficient statistical power for the analysis, and also because of the specific topography and atmospheric dynamics in the city, which often lead to buildup of air pollutants, especially in winter months. So it was an ideal setting for such a study, although we acknowledge that in future we should expand the analysis and cover other major cities in the country. The data sources, so we obtained daily air pollution and meteorology data from the background station located in the Hippodrome Park, which we chose as it was the only one that was of sufficient quality and provided data for the entire 10-year period of interest. So we looked at the daily incidence of asthma and air pollution concentrations in the period January 1st, 2009 until December 31st, 2018. And it was also the only official monitoring station, state-owned station that had data on PM 2.5. Hospital admissions data came from the National Health Insurance Fund of Bulgaria for the same period of time, and we specifically focused on acute asthma cases under the ICD code, so this is the International Classification of Diseases code J45. And we stratified the results and present them separately for different age groups because they're, from the literature, it's known that they have a different likelihood of reacting to air pollution, with younger children typically being more vulnerable or susceptible to air pollutants. So we disaggregated the asthma cases by age groups 0 to 4, 5 to 14, and older than 14. This is the format of the data set that we constructed. So for each of the days, we average the pollutant concentrations because they were provided as hourly averages, but we needed them in a different format. So for each day, we had the number of asthma cases and as well as the respective concentration of different pollutants. So overall, we had over 3,600 days in the data set. In terms of statistical analysis, first we carried out descriptive statistics to get an understanding of the bivariate associations in the data set. And the main analysis was actually a time series regression. So we chose a negative binomial model with a log link function and adjusted the standard errors of the estimates to correct for autocorrelation in the data, which we found. So basically the residuals every n days apart were correlated, which is typical for time series data. And the coefficients of risk we used were incidence rate ratios, which basically tell us the risk of hospital admission for asthma in Sofia in association with 10 microgram per cubic meter increase in most pollutants, except for carbon monoxide, for which the risk is expressed for 1 milligram per cubic meter increase. We looked at the effects of same-day pollutant. So this is lag 0, and also lagged exposure. So whether there were delayed effects. So we were interested whether air pollution on a given day increased the incidence not on the same day, but also on consecutive days within a week at that point in time. And also we looked at weekly average pollutant concentrations. The models were adjusted to account for residual compounding, for temperature and relative humidity, which we modeled as in deciles, so to allow for nonlinear effects of those variables, which are known to exist. We also adjusted for month of the year to make sure that the estimates were actually representing the effect of air pollution, not simply of time of the year, which is also in itself associated with asthma. And the autocorrelation every 7th day actually suggested that we had to adjust for day of the week, because people are more likely to be registered. Their hospital admission is more likely to be registered on certain days of the week for various administrative and other reasons. So we had to account for that in order to get a more unbiased estimate of the effect of air pollution. And lastly, we calculated the population attributable fraction. So basically the percentage of cases of asthma that would be avoided, or how much the asthma admissions would be reduced in a counterfactual hypothetical scenario if air pollutants were reduced to 0, in order to get a more tangible estimate of the burden of disease. What do the results show? So here are descriptive statistics of air pollutants. Nothing particularly interesting here. Everyone who has worked with the official data from monitoring stations is aware of the correlations between specific pollutants, as well as their variations in distributions. But this was needed in order for us to scale properly the estimates. Then we plotted to visually inspect the associations between pollutants and asthma admissions, we plotted the monthly average concentrations of pollutants, as well as the monthly sum of asthma cases for the various age groups. So through the eyelashes, one can see that there probably is some association between air pollution and asthma. Since on winter months, people tend to get hospitalized more often, so there are more cases in such months, although this is not a stable trend. And of course, air pollutants also follow such an annual trend. However, this is insufficient in order to prove causality, so that's why we moved to proper statistical analysis. So these are partial autocorrelation plots, which basically show why we had to adjust the standard errors in the model. Initially, we started with a Poisson model distribution, but due to over-dispersion in the data and some zero inflation issues, we had to switch to a negative binomial, which is also standard in the field. So to account for these spikes, which indicate autocorrelations, we did all those adjustments, and to a great extent we could handle them, even though even if we hadn't done that, they were not major. So the autocorrelations were less than 0.15, which is not so concerning. And these are the main results. So basically these plots show you the risk of hospital admission for asthma for every 10 microgram increase in PM 2.5 and PM10, and the bottom row shows you the risk for 1 milligram increase in carbon monoxide. So the horizontal, the thick horizontal line is basically the null effect line. So each estimate, which has its whiskers, so those are the confidence intervals on one side of the line, is statistically significant, and I have highlighted those. So as you can see, we didn't see anything major for particulate matter, which was unexpected. So we were anticipating much stronger effects, but still we did observe some significant effects on specific associated with specific lags of exposure, mostly in younger children. And carbon monoxide, however, was very strongly associated with asthma admissions, especially in children, reaching 75% on lags 0 and 1 in the 0 to 4 age group. And the cumulative, so the 3-day moving average and 7-day moving averages were anywhere between 14 and 43% for every microgram increase in the youngest age group. Here you see the effects of gaseous pollutants, NO2, SO2, and ozone. So the picture here was more clear, especially in younger children. NO2 was significantly associated with asthma on the same day, so 5% risk for every 10 microgram increase. And if we looked at the weekly effects or 3-day moving averages, the risk was about 5 to 10% in younger children, and similar in older children. SO2 was the most consistently associated with asthma pollutant. Again, in children, not so much in adults. And the average weekly effects even reached 35%, which was quite substantial. So, in essence, looking at the population attributable fraction, so the percentage of admissions that could be attributed to the actual levels of pollution compared with a zero pollution scenario, actually show that if the weekly average concentrations of SO2, O3, and carbon monoxide were reduced to 0, that would reduce the number of cases of hospital admissions by anywhere between 13.5 and 23.5%. This is in children. In young children. In older children, 5 to 14 years, these fractions were anywhere between 8.8% and 10.9%, so around 10%, which is quite substantial. In adults, however, we didn't see these effects, and we speculated that the differences could be due to many things, like exposure misclassification, because adults are more mobile in their daily life than children, so the exposure data may not have actually represented so accurately their exposure to air pollution. Also, adults have better coping mechanisms, behaviorally, I mean, on high pollution days, unlike children. So there could be many reasons, which unfortunately we could not explain, but this is a trend that is often seen in the literature as well. Children have a higher risk than adults. And as for limitations of the study, so like any study of this sort, looking at short-term effects on a population level, it was an ecological of this in terms of design. So that means that we used aggregated data on population level. We didn't have data on specific subjects as with other study designs. So this means that the risks can be interpreted as risks in the entire population of Sofia. But that doesn't necessarily translate into individual risks on the individual level. But again, this is quite standard. So the effects are more relevant for public health than for clinical practitioners. We also couldn't ascertain that the air quality data was equally representative of all residents of Sofia, because we only use data from one monitoring station due to lack of sufficient available data of the same quality. This also means that we may not have properly captured the temporal variations in air quality. So that could explain some of the now effects in adults, for instance. And finally, as I mentioned, we did observe some zero inflation in the data in the younger age group. So basically a lot of days on which we had 0 cases of asthma admissions, which is statistically might be a problem for the model. There are other options that we chose not to pursue because we couldn't find a clear mechanism that was generating these zeros, so a clear predictor, and we decided to stick to the classic negative binomial models. But comparing some zero inflated models with negative binomial models, we didn't see any major difference in the risk, so that was reassuring. And as for the conclusions, looking at the entire body of evidence we generated, so in the child population, mostly gaseous pollutants increased the risk of hospital admission for asthma at different lags by anywhere between 5 to 10% per 10 microgram increase in NO2 and O3, and reaching a 75% per 1 milligram of carbon monoxide. However, mind you that this is probably due to the fact that the distribution of carbon monoxide values was much narrower compared with other pollutants. So basically, this was an exaggerated risk simply because 1 unit increase in carbon monoxide was a much larger share of its statistical distribution than for NO2 and O3. And as I already mentioned, approximately 13 to 24% of the admissions in young children and 10% in old children were attributable to the average weekly concentrations of gaseous pollutants compared with the hypothetical scenario where concentrations would be reduced to 0 and no clear effect was found in adults. Thank you.
Thank you for your speak. I'll just ask to ask Professor Neki. Come here.
Мога ли да управлявам? Не. Може. Hi everybody. My talk will be about forecasting our hourly nitrogen, ozone, and PM10 concentration using daily data analytics models at Pavlov Station in Sofia. As you know well, forecasting is difficult, especially for the future. Next. This is a part of in-air project, and one of the sub-goals of the project was to develop data analytics model to forecast 48 hours ahead the hourly concentration of air pollution data. Hourly air pollution concentration data are collected at Palu Urban Air Quality Monitoring Station by the Executive Environmental Agency in Sofia for the period 1st January 2090, 7 May 2021. Data analytics models will be based on will be a combination of numerical weather prediction model and stochastic models. We will use weather research and forecasting model, WRF, which will deliver 48 hours forecasting of different atmospheric parameters. I will show which one. And because we are going to forecast 48 hours ahead, then it is not allowed to use last 48 hours. So this is one of the problems. And these are the parameters that will be used. Can you see well? These are temperature at the surface, dew point temperature, soil temperature, etc. I will not be explaining about the data. Very important is the quality of the data because they are characterized with a lot of missing observations. For instance, the 20,592 hourly concentrations, but 12,913 are missing. So we have to improve the quality of the data with appropriate statistical methods. For this purpose, we need to find very well distribution of the missing data. For instance, PM concentration 10, 304 observations are missing. This means 800 and 304 cases. In this way, we can calculate the whole type of missing data. 1,476 observations are missing for NO2, 626 about ozone, and 9,811 observations are missing. Well, there are different, these missing data are with different gaps. And here is a detailed statistics. One missing observations, for instance, in NO2 is 341 times. 297 missing observations is only one. This is a very large gap. This is because of the failure of the equipment. It's not possible to replace this with mean value. We need models to recover these observations. Here is the distribution on this slide is the distribution of PM10. You can see the on the slide of upper left slide, you can see the distribution during the months that in the cold half of the year, the concentrations are very high. On the right upper slide, you can see the hourly distributions of the PM10. And this is the distribution on the left lower panel, the distribution during the day of the weeks. And the last panel, this is about the weekend and weekdays distributions. The same distributions are about NO2 and about ozone data. Well, you can see that during the hours, in the afternoon hours, the concentration of ozones are very high, which is well-known fact. And during the summer, the concentrations are high. Now, the distribution histogram is very important because we are going to use log normal distributions, and the original is from the left and log normal, but log normal is highly non-normal, even though with logarithmic transformations. So we need a complex distribution in order to model this data. How can we do this? With a mixture of distributions, because mixture of distributions are, it's well known, they are very good approximation, just like, so let us consider XT as predictors containing meteorological parameters. They are lags in order to find the prehistory of the process. And here you can see this is a linear combination of normal distributions. I am using normal because we'll take logarithmic transformation of the pollutants with a lot of parameters. What is this TG? These are probabilities, weight of any one of the distributions. And from the more normal presentation of this mixture of distribution with probability P1, the model will follow one of the models. We've got G models. This is correspond because the data are highly heterogeneity. This corresponds to different synoptic situation. For any one of these situations, we possess one model, and their linear combination approximate the true distribution of the data. These P distributions are in fact neural network we call in statistics multinomial logistic regression from due to the meteorological parameters. These probabilities jump from one state to another state or remain in the same state. And in this way, we get this complex distribution. The optimization process is with constraints because these are distributions should satisfy this condition. Some of these P probabilities should be equal to 1. Because of the many parameters, meteorological parameters, they are lags. We use optimization with another additional constraint, which is called lasso. We minimize a special theoretical norm over the parameters. In order to select the optimal number of component of these complex distributions, we use Bayesian information criteria. which is defined below. Well, how to validate the model when we're training the model over train data set and test data set. For this purpose, we split the data in two parts. 17, yeah, not possible. How to it? The tested period is from 1st January to 5th May, the May of 5th. And the first part for training are periods in blue. For the testing period are with red and green. We estimate the parameter in first fault containing the first row of for the period 1st January till last day of 2020. Then estimate the quality of the feed using 2 days, 48 hours from the 2001. Then we add this data to the training set and select next 2 days in order to evaluate the quality of the feed. In this way, this is called a rolling forecasting region cross-validation technique, which is well known in time series technology. In this way, we can select such from many models because the number of models is equal for any one of the pollutants, 2 in power m when m is the number of the predictors. Because the number of predictors is more than 250, we get a lot of models. So we have to select some of these models using Bayesian information criteria and some of the measure which you use for the quality of the feed, like correlation between predicted and observed over the tested data, mean absolute error, root mean square, and here are the quality of the graphical model assessment about NO2 for the any 2 consecutive days for 3 days period, for 6 days period. With the red are the presented on this slide. In the red lines are the original data, and with blue lines are predicted value for the same model for different period of times over the tested data in order to have an impression about the fits. This is about the ozone, the same technology. Red are observed, with blue are predicted. For any 2 days, we saved the prediction and then plot for 145 hours ahead. For different part, for January, this is when we use information about the number of vehicles for the, however, these data are simulated. Those presented with red, these are the same simulated data in red in all these panels, and with blue on are the predictions. And when we use with the WRF and lags of the data. These are on the two upper panel. And when we use only such deterministic time series regression model based on finite Fourier transform, on a finite Fourier, then we've got these panels which are in the lower part. So I think we, based on this metric characteristic and quality of the fits, based on a graphical assessment, we were able to develop models with good forecasting qualities. So they may be used for such purposes. It was part of UNOAIR project. So some literature concerning this technology of highly nonlinear, non-Gaussian modeling. This is about this presentation.
Thank you, Michael. I would like to give the floor to next presentator, Elena Christie.
Hello, can you hear me?
Yes.
Okay, I'm going to share my presentation now.
Margaret, now will be Elena Christova.
Oh, okay, I'm sorry.
Hello, everybody. Thank you for the opportunity to be here and to present our studies. That is my second presentation on topic of past and black carbon.
Колеги в студиото, издърпайте ли микрофона по-близо до вас? Не се чува.
Okay, it's okay now? Okay.
It's better. Thank you.
Today, I am going to present our work on polycycle aromatic hydrocarbons and black carbon in urban air particulate matter in Bulgaria. My presentation will follow the listed outlines over the screen. Fine particulate matter is a key air pollutant associated with adverse health effects, but also affecting the climate and environment around us. Many sources may contribute to PM2.5 levels, such as traffic, dust suspension, biomass burning, etc. The composition depends not only depends mainly of the origin of the place and the sources. One of the light-absorbing substance is black carbon, which is a carbonaceous aerosol formed through the incomplete combustion process, with unique physical properties presented here. Depending of in which wavelength is absorbing the light, we can differentiate the black carbon from fossil fuel combustion and brown carbon from biomass burning. The other substance is polycycle aromatic hydrocarbons, which is they are semi-volatile organic compounds also formed during the incomplete combustion process and precursor of organic matter. They can group in depending of the number of rings their composition, or also in general divided into three main groups, like a low molecular weight, medium molecular weight, and high molecular weight. which I will use future in my presentation. Also, I will continue to use PAH as a short name. Why we choose this both species? Because a significant proportion of high particulate aerosols is comprised by black carbon. Because its harmful effect on the environment and human health, and also a lack of information about the concentration of black carbon in Bulgaria. For the reason to choose the PAH, that's because of their mutagenic and carcinogenic nature. Only one of 16 priority species are under regulation and measured in Bulgaria. Here you can see that we continue to reach to exceed the annual norm of benzoapyrene in many stations in Bulgaria. The aim of our study is to study the concentration of black carbon and PAH bound to 2.5 PM in two big cities in Bulgaria, Sofia and Burgas, based on parallel experimental campaign during the autumn, winter, and summer. As the sampling sites are placed at Sofia at Central Meteorological Observatory, and in Burgas and in the yard of University of Professor Dr. Hussein Zlataru. The main procedure that we follow, each sampling site operated two parallel PM2.5 samplers with a different filter media regarding the future analysis. Here, I presenting the mean PM concentration for these 3 periods of studies. You can see that the concentration of PM2.5 in October and July are higher in Burgas in comparison with Sofia, and the opposite during the winter time, which is we expected because the topography and meteorological conditions in Sofia Valley, and also the more intensive emission sources during the winter time. Here on this slide, I'm presenting the comparison of the obtained value for black carbon, also for Broad City in these 3 periods. And what we observe that in October and January, February 2021, January the concentration of black carbon is higher in Sofia and a little bit lower in Burgas, which we can explain with the more intensive traffic during the holidays and touristic season during July. And on the graph below, I'm presenting the mean brown carbon concentration. And you can see that the concentration obtained for Burgas for October and July is higher than in Sofia, and the opposite also for January, February 2021. We explain this pattern due to the because the station in Burgas is very close to the agriculture area, and maybe there is influence from burning or around this area, biomass burning. On this slide, I presented the comparison for low, middle, and high molecular weight packs, and also the sum of them for Burgas and Sofia. Generally, the concentrations for all packs are higher in Sofia in comparison with the Burgas, And for July 21, we observed that the concentration are almost the same in both sampling sites. Here, I'm presenting the correlation coefficient between PM associated with PAH and black carbon, brown carbon, and PM 2.5 concentration. And you can see that there is a very good correlation between concentration of fine particulate matters and black carbon, and also PAH for Sofia. And also very good correlation for PM 2.5 and black carbon in Bulgaria, but lower correlation with PAHs in Bulgaria. For estimation of cancer risk of PAHs, we know that all PAH compounds have carcinogenic and mutagenic potential, but benzoapyrene is considered as the strongest one and is often used as indicator of human exposure of PAHs. For estimation the toxic equivalency of the total PAH concentration, the carcinogenic potential of individual PAHs are expressed relative to the potency of benzoapyrene as the concentration of each individual PAH compounds. And also we did additionally calculation excess cancer risk for inhalation, which can be calculated as presented here on this slide. The data which we observed is presented here in this table on average and also the range of all coefficients. And as we expected for Sofia, this TEQ coefficient is higher, and we can say that we have above the limit value of 1 nanogram per cubic meter for annual daily limit value. And in order to identify the source of PAH in PM, we calculated the diagnostic ratio. This is a very often used by different scientists, and you can maybe you can probably, but difficult to see the numbers, but I will mention the conclusions in our conclusions from this table. To sum up, I presenting the primary result of determination of the most significant components in urban fine particulate matter in 2 Bulgarian cities. For differentiating of contribution of source for biomass from biomass and fossil fuel, we use MABI, and the results shows that the higher mean PM 2.5 concentration in Sofia was observed than in Bulgaria during the winter, and the opposite during the October and July. The derived BC value for Sofia are higher than those of Bulgaria. Also the correlation between BC and PM 2.5 for both sides suggested the elimination of fossil fuel combustion contribution for the fine particulate matter than biomass burning. And diagnostic ratios indicated that all PAH sources are more pathogenic with prevalence of traffic emissions. We believe that our study leads to better understanding the PMM composition and its sources. And I would like to mention that this study was done during the COVID period, and we will see now what will happen after everything goes normally. And the sampling and analysis for all components continue. Also, I'd like to mention that all data and analysis are in frame of the our project Carbon Result. Thank you very much.
Next speaker will be Margaret Velizarova.
Thank you. So I'm going to talk about the impact of regulatory measures on pollutants concentration in urban street canyon. There is no doubt that air quality at the street level directly affects human health. Also, the lack of ground air quality data makes the assessment of the air quality at street level a difficult task. And the main challenges in local scale air quality modeling are the lack of enough observational data in order to represent the meteorological fields more accurately within the models, and that the emission inventory from transported domestic heating is the most uncertain part of the air quality modeling. And thus we need new approaches, methods, and tools in order to develop and apply those and apply them to those sectors in order to reduce the discrepancy between measurements and modeling results. For the study, we used the local Gaussian dispersion model ADMS Urban, which was developed by the private organization Cambridge Environmental Research Consultants. The simulated area consisted of 44 streets and boulevards divided in 160 road segments, which were located in the center of Sofia city, and the grid resolution for the simulations was 5 meters, and also we used 28 vertical levels. The segments, the road segments are described within the model as road sources, which means that the emission height is adjusted to account for the range of heights of vehicle emissions. And the horizontal turbulence describes the additional traffic produced turbulence. For the meteorological input, we made simulations for 1 month from January the 3rd to February the 3rd, 2020, using the advanced research version of the WRF model, which delivers additional meteorological parameters which significantly improve the description of meteorological conditions and ensures better air quality results. The emissions are obtained using the atmospheric emission inventory toolkit, or EMIT, with input data from Sofia Directorate of the Internal Affairs, Sofia Municipality Public Transport Directorate, and other sources. More details on the specific methods and tools that have been applied for the development of the transport emission inventory scenarios can be found in the paper Transport Emissions from Sofia Streets by Burov and Brezov. As I said previously, the emissions were calculated using the EMIT. The simulated measures cover restriction on entry into a low emission zone for Euro 1 and Euro 2 classes when the nitrogen dioxide concentration is between 100 and 150 micrograms per meter. Also, there are restrictions again on the entry in the low emission zone for Euro 1 and Euro 2 classes when the nitrogen dioxide concentration exceeds 150 micrograms per cubic meter. And if the nitrogen dioxide concentration exceeds 150 micrograms per cubic meter for 3 days, the vehicles from Euro 1 to Euro 4 are banned from entering in the low emission zone. There are also 4 cases with implemented restrictions on entry into the low emission zone for 2026 and 2030. 2 cases where the traffic was unaffected. It was the same as the base case scenario. And 2 cases with 20% traffic reduction. In the table, is given the description of the different cases based on traffic and contribution of different categories to this traffic. Model verification was made using monthly mean concentration values of nitrogen dioxide at the measurement site, which is 57.5 micrograms per cubic meter. On the left figure are presented the monthly mean concentration values of nitrogen dioxide for all of the modeled cases at the measurement site, which is shown on the right map, and is near the crossroad between Boulevard Vasilevsky and Georgy Rakovsky Street. The measurements were made at 2.5 meters height. The airbag volunteers have been installing and assembling small diffusion tubes containing a chemical substance, which is absorbing the measuring component. And after measuring for 28 to 30 days, the tubes are sent to Passamedi laboratory in Switzerland to provide results. The obtained modeled values of nitrogen dioxide are presented in the table. From the graph, we can see that the monthly mean concentration decreases, which is more with more considerable reduction of 14 to 17 micrograms per cubic meter for the cases with 20% traffic reduction compared to the cases without, where the reduction is approximately between 8 to 4 micrograms. 4 different emission scenarios are compared with the base case scenario, which is in blue. These plots present the monthly mean vertical profiles of nitrogen dioxide concentration at the measurement site for the cases without traffic reduction on the left and with 20% traffic reduction on the right. The first thing that we can notice is that for the cases with 20% traffic reduction, the concentration is considerably lower than the base case and the cases without traffic reduction. Another conclusion is that approximately 12 meters height, there is a slight increase of the concentration, which might be due to the formation of recirculation zone inside the street canyon. Rakovsky Street is a typical narrow street canyon with average ratio of 2.21 that is favorable for vortex formation inside the street. Here are presented the hourly monthly mean profiles of nitrogen dioxide averaged over the entire domain for all of the considered cases, again without traffic reduction on the left and with traffic reduction on the right. There are 2 prominent peaks in the concentration around 8 a.m. and between 5 and 6 p.m., which correspond to the rush hours related to travel to and back from work. Again, the concentrations for the cases with traffic reduction are lower than the concentrations for the base case and the 2 cases without traffic reduction. Here on the left plot are presented the hourly monthly mean profiles of nitrogen dioxide concentration for the base case by weekday. And on the right plots are presented the differences between the hourly monthly mean profiles of the base case and the first case for the year of 2026 without traffic reduction at the top and with traffic reduction at the bottom. The differences with traffic reduction is greater than the difference without, almost 3 times. The differences in the concentration without traffic reduction reaches values of about 1.9 micrograms per cubic meter, and with traffic reduction about 6.5 micrograms per cubic meter for Wednesdays. The hourly dynamics of different days of the week is different, with the lowest traffic during the weekend, which significantly affects the concentrations. Here on the left is presented the monthly mean concentration field of nitrogen dioxide for the base case. In the middle is presented the difference between those fields between the base case and the case for the year of 2026. And on the left is presented the difference between the base case and the second case for the year of 2030 without traffic reduction. The greatest differences occur along Georgy Rakovsky Street, Boulevard Vassilevsky, and Boulevard Patriarch Eftimi, and are more prominent at the crossroads between them. For the first case, differences in the concentration values reach about 10 micrograms per cubic meter, and for the second case, about 25 micrograms per cubic meter at the crossroads, and also along the street segment between Arachudimchev Street and Graf Ignatiev here, if you can see my cursor. Here are presented the same figures as in the previous slide, but the figures with the differences are with 20% traffic reduction. Again, the greatest differences occur along the Georgy Rakovsky Street, Boulevard Vassilevsky, and Boulevard Patriarch Eftimi, but they reach values between 15 to 35 micrograms per cubic meter along the roads, and above 60 micrograms per cubic meter at the two crossroads. The measures with additional traffic reduction affect more significantly the pollution reduction inside the street canyon. And the conclusions are that the model slightly overestimates by 7% the observations of the monthly mean concentration of nitrogen dioxide at the measurement site. The 20% traffic reduction led to 2 times lower pollution compared to the cases only with a restriction on entry into the low emission zone. 2 prominent peaks in the nitrogen dioxide concentration around 8 a.m. and 5 to 6 p.m. correspond to the rush hours related to travel to and back from work. The hourly dynamics of different days of the week is different, with the lowest traffic during the weekend, which was 2 times less at the rush hours. The effect from the low emission zone implementation is greatest along the Georgy Rakovsky Street, Boulevard Vassilevsky, Boulevard Patriarch Eftimi, and at the crossroads between them. Despite of the applied measures, the concentrations at the crossroads remain more than 150 micrograms per cubic meter and require further investigation and probably application of more strict measures. This study demonstrates the promising abilities of the new methodology, which includes high-resolution air quality dispersion modeling, coupled with the numerical results from regional meteorological model and the new developed sector emission inventories for road transportation. And this will be a useful tool in making scenarios for the future in order to reduce the emissions, and this can help the authorities with decision making. The limitations of the study are that due to the lack of ground air quality data, the extensive model verification becomes a difficult task. Also, the ratio between nitrogen dioxide and nitrogen oxides was estimated using data from AQS PAVUVU, which was very high, and it can be a possible reason for the overestimation of the average monthly value by the model. Also, measurements at more traffic sites are needed in order to estimate the real traffic structure and ratio between nitrogen dioxide and nitrogen oxides. More simulations are necessary to cover the entire year of 2020 in order to compare the modeling with results with annual limit values for the protection of human health. And the extended modeling domain which covers Sofia municipality, will ensure more reliable results for air quality related to road traffic in the entire urbanized area. We would like to thank the research fund at the Bulgarian Ministry of Education and Science and the NCDSE for supporting our work. Thank you for your time.
Thank you. Now we will continue with questions and answer session. If there is some question, please ask.
I have two questions, Dr. Gadjev.
Yes, Professor Cherenkov.
My first question is to Dr. Bozhilova. Your research relies entirely on ground-based sun photometer measurements, right? And my question indeed is, have you tried to utilize different remote sensing products of the UVA and UVB, UVA and UVB quantity in the total ozone column? Because there are plenty of such UMETSAT products with very high resolution, very robust, with very high quality.
Sir, you referred the question to Rumiana Bozhilova, but her presentation was recorded, so she's not able to answer your question right now.
Yes, and my second question, it's a small remark, it's not a question. Indeed, to the last presentation to Ms. Margaret Vilizarova, are you sure that the Georgy Rakovsky street satisfies purely geometrically and topologically the condition for street canyon? Because I'm completely not sure. The street is curved with many junctions, its main points for ventilation. According to my opinion, there is no such structure in Bulgaria at all. We have not street canyons here in Sofia or in Bulgaria at all. You have to use this terminology more precisely. Thank you.
Thank you too. Well, I would like to say something if it's okay. It depends on which type of classification which type of classification you're using for the street canyons. For example, I have forgotten the name of this classification, but when the ratio between the height of the building and the width of the canyon is larger than 0.65, it is considered a very strong type of street canyon, I mean, and for Georgy Rakovsky Street, this ratio is 2.21. So it depends what you're using as definition of the classification of the different types of street canyons. Thank you.
Yes, but the street is open in both directions in any junction. It's not closed area. It can be ventilated in both directions. That's why it can be considered a street canyon.
Well, yes, it depends on the viewpoint, but it depends mostly on the wind direction. I don't know if it is always channeled. I guess not. I mean, yeah.
Are there any additional questions from the audience? Okay, I cannot see additional questions, so now it's a time for the lunch break, and we will see each other again at 1400, which means 2 p.m. So please be back on time. And now I would like to ask the personnel present here who did not receive
So welcome back. We're moving forward with panel 5. Again, we have informatics, remote sensing, GIS, high performance computing. 5.1, we have a remote sensing, informatics and models. 5.2, GIS for environmental monitoring. 5.3, high performance computing, MNS, and artificial intelligence. The first presentation is by the director, the chief of the Optical section at the center here at the CMDR COE, Colin Lazarov. He will enlighten us about database for AI training data sets, functionalities, and pre-processing. We will have a FUSEGI project presentation after your presentation. Dr. Petya Trifonova from Methodimetodia will talk about verification of 2020 geomagnetic models over the Bulgarian territory. Dr. Nina Dobrinkova, who I guess you saw the first day of the conference, will present about the Bulgarian platform for natural hazards data collection and decision support in field operations. And the final paper of the session before the break, around 4 o'clock, will be the creation of time series from ASR data for landslide investigation by Dr. Mila Atanasova, who will be presenting this paper, which she produced with Chris Nikolov and Ivan Georgiev. Welcome to the session, and the floor is yours. Thank you.
Thanks, sir. As I was introduced, I'm a section head of our Ops Lab. This is the most, I can say, the most innovative part or unit of the Center of Excellence. So there we can play with a lot of concept, doctrines, ideas. Actually, our level is very abstract and not so tight related with European documents or NATO documents, etc. So a year ago, we started a new project, another project, which is something very interesting for us. Again, the level is scientific, and it's about space weather. Why is it so important? Because our Earth actually is surrounded with this environment. So later, from OpsLab, we proposed to extend this research, this scientific research and modeling, trying to find possible correlations between space weather parameters and processes on Earth. So it's not just about disasters or such crisis events, most of them with negative impact over the society, but actually we'd like to find is there correlation between any kind of technological, societal, or natural processes on Earth and some changes of the parameters of space weather. It was very well accepted, actually, and as a proof of it, actually, we received a specific budget from Science and Technology Organization of NATO to develop specific interfaces, products, and to perform this research and analysis. In order to do that, of course, our research at this moment, thank you very much, is based on artificial intelligence, because nowadays this is the very fast approach in order to model something. And talking about the database and why do we need it actually in our project, the first is the problem. Talking about modeling now, because there are so many different types of modeling. We have classical differential equations modeling. We have artificial intelligence modeling, which is just one of the technologies of AI. There are so many others. We have another types of modeling, but most of the time we have data which we use, as a source for our modeling. Then we process this data and we have specific outcomes. Most of the time, this is the model. It could be a system of equations, mathematical equations, and later we can make predictions. We can analyze the process, etc., etc. The same is the same issue. The same approach is with AI training, but the efforts, the human efforts, significantly reduced in this case. Again, the crucial thing is the data, because it's absolutely valid. If you feed the technology or the methodology, it depends on what we use as a modeling process. If we feed it with data with good quality, let's say, you'll receive a really well or useful model. In other case, it could be accurate for just a very limited range, for example, or very limited time. In order to have such data with good quality, we should cover the whole range what we'd like to model. We have to have accurate data, of course, without noise, etc., etc. And yeah, the data for modeling process is something very, very crucial and important. In order to solve this problem, we'd like to develop a specific database storing necessary data for AI training. In our case, as I said, from one hand, we have as an input data space weather parameters. So this is dangerous actually for ourselves. These charged particles or solar wind coming from the sun. Fortunately, we have this electromagnetic shield around the globe, around the world, which protect us, of course. However, outside of it, we have sensors on different satellites, and they are capable to record, to measure what are the parameters, actual parameters of space weather at the moment. And now we'd like to connect this data with some statistical data coming from Earth. So in artificial intelligence, this means that we have input data and we have target data. Target data could be, for example, the deviation of the accuracy of GPS signal. It could be some health problems, for example. If we have specific space weather parameters, we can expect influence over the human body. So we'd like to see are there such correlations. And we have input data, we have target data. Then the problem is just to adjust, to tune, to make the appropriate structure of the AI in order to generate a good model. What does it mean? There are many already prepared different structures of AI. You could be familiar. We can find their neural networks. They're limited time. They are not limited types. There are not so many, but you can combine them in different ways in order. It's like magic, let's say. But you can tune them and adjust them in order to achieve this good accuracy and to make accurate model at the end. Why? Because in future we can predict what will be the effect, what will be the effects, what will be the impact over Earth if we observe specific space weather parameters. That's why the input data is so much important for us, and we need a place where to store them. And we started this subtask in our project to create a database. But to create just database is not enough for us. We'd like to make something more. We'd like to develop specific engine attached to this database, and this engine will make our life easier when we perform specific iteration of AI training. What does it mean? I'd like to, for example, I'd like to perform such iteration or training the model, creating a model, AI model, with specific data frame. This means that on the left, for example, I will have space weather parameters. What I have, there are limited number of parameters. For example, 5 or 10. One of them could be image of the sun, for example. Another will be some values describing the solar wind. So these parameters I will have on the left. On the right, I will have some parameters coming from the Earth, for example. It could be statistics about floodings or earthquakes around the globe. And AI will try to find what is the relation between them, how they could be connected. Later, when we have this model trained, we can have accuracy like 30%, like 50%. We can have accuracy like 99%, which is the best solution actually, because in this case we know that we have very hard correlation between input data and target data. So we can expect we have very strong connection between these two events. So in order to do that, some preprocessing should be done with the data, which is something very boring and consumes a lot of effort. This is not how to say, so satisfying part of AI modeling. First, we have to check do we have the correct data. We have to see if there is a null, for example, values in this time series, because let's say that we have statistics about traffic incidents, and we have statistics about every year, but for 2019, for example, we don't have any kind of data. So we have one very long time series, and we have something empty there, all null values. It's a problem for the AI. And the results, if the model could crash immediately, actually, which is maybe the best case, could crash after 1 month of computing, which is of course not so good, because we use some very powerful machines. We created such a workstation here in CMDR COE in order to train our models with some very specific equipment based on, I can say it, on NVIDIA A100 modules dedicated specifically for such calculations. 1 month after starting of computation is a risk. I mean, to have such crash. So in order to avoid it, we have to check the integrity of the data. Another thing is check for some mismatch, because I'd like to search for this correlation, explain correlation, but I have here specific period of time, specific range. On the other hand, maybe this time series, another time series is shifted with a specific time, and in this case, it will be another problem. Of course, there are some solutions we can shift, and we expect such things. In the interface, operator interface of this database, we'd like to have such opportunity, operator to choose time shifting between these two series. The advantage of this approach is that later, let's imagine that we have specific space weather, and we can't expect to have the impact immediately on Earth. Maybe we can expect to have some effects on Earth with specific delay. For some processes, this delay could be several hours. To have a headache, for example, or something like this. For other, it could be even a month. I can say that when we started with this idea to make such comprehensive research and analysis, we found that similar researches were already made, but in very specific directions. One was very interesting. It was about problems with power electrical grids, and specifically with transformers, powerful transformers, very expensive equipment. And there is pure, very easy to observe connection between space weather and this very expensive equipment. So in future, if we have the information in advance about what is coming from space, we can take some precautions, we can take some measures in order to protect this expensive equipment, not only because of the cost, but also to prevent our critical infrastructure and power grid, which is something very useful. And yes, we'd like to make this research much more comprehensive and to include many others events and processes. What else? We expect to have not only space weather as an input data on the left side, let's say, and target to be just processes on Earth, but to have also some processes or parameters of such processes on Earth combined with the space weather. So in this case, we could enlarge or extend our model and can make it much more precise, adequate, and useful at the end. Because if we have something very accurate, we can use it in very extended range. About the resolution, we have to normalize our data in advance. What does it mean? Artificial intelligence doesn't like so much bigger values. For example, 5,000, 1 million, it's not so applicable to artificial intelligence, at least this technology which we are using at the moment. Instead of that, we use very limited range. It's about from 0 to 1 most of the time, or -1, +1. This is the range. And in order to do that, it's a very simple equation how we can normalize the data coming, or this 5,000 or 1 million to change the scale in order to fit this very simple range. Actually, we don't, we don't change so much the data. We just change the scale in order to make the AI computing and modeling much more faster. Because when we try to make something with very limited input time series or parameters and respectively very limited data, it will be computed very fast. It will take us, for example, several minutes, 1 hour. But when we enlarge and add more and more data, which is very helpful, it could create much more precise model. We need very powerful machines in order to compute the result. And it could take us really months and even years. In order to avoid that, we have to make some efforts in advance and this pre-processing. I already said all these things about space weather correlation. The name of the project is MSG 187, I think. And yeah, this is these three domains: social, natural, technical, and we have space weather on the one side and Earth domains on the other side. About the possible combinations and variations, because we can perform AI training with many different combinations and variations. For example, we can expect from Earth domains to have so many different processes. You can imagine, we can imagine, for example, financial statistics and how these variables could be related with space weather. Imagine that we have specific energy coming from space, from the sun, for example, which is the biggest energy source for our planet. So this energy is coming constantly, but it's variable. It could be reduced or increased, and it will affect the power consuming on Earth. So we can consume specific fuels or electrical power, etc., etc. And of course, it will affect the prices of these sources of energy. So there is, again, another relation between space weather parameters and something very interesting as prices of the stocks. This is just as an example, but we can give so many other examples like this, and we'll have many possible combinations and variations between space weather parameters and as input data and target data. On the slide, this is elaborated how we'll have for sure as input data space weather parameters, but they could be enriched with another time series coming from Earth processes statistics. Finally, the AI model will try to find these correlations and relations between these parameters. About the database schema, we plan to use the PostgreSQL as a database for us. Why? Because it's free, I have to say, and because it's good enough. It could be Linux or Windows based. We plan to have specific hardware which will run this database, and we need something very, very flexible because tomorrow we already start with specific statistic data, but tomorrow we'd like for sure to put something else there. It could be images, it could be, I think that it's explained later, it could be images, it could be integers, floating types of data, any kind of values in this schema. The more important is that trying to collect all this data, we have to have many different interfaces. For example, specific statistical data could be provided to us in XML format. It could be CSV format or comma separated values. It could be in other formats, even in text formats. And this engine of the database, this interface should be capable to accept this data, to load it into its own tables, and later to extract with a specific interface for the operator. We plan to attach specific metadata to each of these time series with short explanation. What is stored there? For what kind of period is related this data, etc., etc. And again, all these checks and alerts about specific gaps or problems with the integrity of the data should be done by the interface again. Also, we'd like this engine of the database to support our research workflow, not only with preprocessing, but also logging what is, when, what is done, what are the results, in order later to report easily our outcomes. For example, such outcome could be achieved accuracy of the model, coefficients of the model, because later, for example, if we receive something useful, if we achieve something applicable, now we are talking about the industry, it will be very easy to send them the shape of the AI, what is the structure of the AI, what is the summary of the AI, how many neural networks, for example, are there, what are the connections between them, how many parameters, and we can send also the coefficients. So this model is already trained. We give them the coefficients, and everybody will be capable to predict what will be the future using this model. Also, we supporting the whole research, now not talking about each iteration. We'd like to record what data frame is used for each iteration, for each small research, what kind of data is there, when was performed the computation, for how long it will be. Also important for us to know what is the achieved results, the inheritance, because we start with something, then we'd like to improve our model, so we can add just one time series, or we can change a little bit the AI model. So it will be useful for us to know that this research, this iteration actually is based on previous one, or specific one. And we can have several branches running simultaneously, and if there is no positive trends, we can stop there, we can continue with the others, etc., etc. Filtering graphs, it's again some opportunities or capabilities of the database to show us where is the progress and where to continue. And that was all for me. Of course, I can explain so many things for this project, but yes, according to the topic of the presentation, yeah.
Thank you very much. It's a great project, very innovative, and highlights the novelty of the center. We can move on to the next presentation. Thank you. Thank you so much. Thank you. So we will have the FUSEGI project presentation, which is GI.
Hello, good evening, everyone. Let me share my screen.
Hello, welcome.
So are we okay?
Yes, we're.
All right, so hello again. My name is Maria Koulouri, and I'm a civil engineer and research fellow from the Democritus University of Thrace. And here today I represent my team from the Erasmus Plus project, which is called FuseGI. So, FuseGI is a 3 years interdisciplinary and transnational project implemented in 4 European countries. The FuseGI consortium is composed by 4 universities, 2 private companies, and an NGO. In total, 4 countries. Of course, as you can understand, its partner plays a key role within the project. So, the project aims in innovative environmental management through a cooperation for fusing skills on cloud-based of open geoinformatics. The planning of the project was originally based on a common observation that young professionals in the fields of environment, health, or even water resources management often lack the practical GIS skills that are requested at the beginning of their careers. So, to fill this gap, our consortium proposed the FuseGI project for funding by the Erasmus Plus agency. In other words, FuseGI aims to deliver practical problem-solving GIS skills and develop professional GIS capabilities to postgraduate students based on cutting-edge ICT tools through a virtual learning environment for remote training. So, what was the innovation? The innovation of FuseGI results from the development of a complete and updatable framework that provides high-skilled scientific staff readily available to the ever-advancing environmental market. The 3 main pillars of the project was forest, water, and health. So, the idea was that FuseGI could support higher education institutes as well as professionals in the fields of health, forest, and water based on 5 main phases. So, 3 years ago, it started with research, benchmarking, and review in order to come up with the design and the whole architecture of the project. And then we had to find the right VLE platform to create the series of the courses, test and validate our material with students, and finally revise and create the final curriculum of the courses. Through these 3 years, 3 multiplier events were organized in Bulgaria, France, and Greece. So, wait a minute. Perfect. So at the beginning, a questionnaire was built with the main question: do undergraduate and postgraduate GIS courses provide the skills that the environmental market asks for? Coming up with the result that professionals identify the lack of GIS training in bachelor's degrees, whereas academics believe that GIS courses are market-oriented. We continued with an analysis of all offered GIS courses in the universities of France, Bulgaria, and Greece. And finally, we had to find the right VLE platform to support our material. Technical and financial comparison of different learning platforms took place, and the winner was Moodle.
And then we had to build the courses, the main material. So 9 courses were created, covering all basic and more advanced topics. Each course contains not only theory, but also practical advices, self-evaluation, quizzes, and external material. We created 3 case studies on the 3 thematic pillars: forest, water, and health, for hands-on practice, of course. And all these were reviewed by students and trainers in the multiplier events that we were organized. So, of course, you all know better than me how important is GIS, used in industries such as urban planning, health, water resources management, even archaeology. So it is very important through these courses for students to understand the importance and use of GIS and to look for such courses on their own. A few words about the courses. They contain the basic theory required for geospatial data in order to introduce students in the practical part, which is the essential use of an open source GIS software. From the 3rd lesson, they will be introduced to the software, starting from the installation step by step. In this point, I'd like to say that we used QGIS as the software because it is an open and free and easily installed software that students can use. So each course consists of a folder of different files, the main presentation in the form of slides, and its presentation begins with a recorded summary of the lesson, a folder of supplementary material, a short test based on its course, and finally, a comprehensive evaluation form. It should be understood that the present courses are targeting a variety of people of different academic levels and fields. So the structure we followed, the theory that is taught, and the information given must be understood by both a graduate student from an engineering school and a philosophy student. So the series of courses is completed with a set of case studies conducted by real-life projects in order to prove in practice the skills and knowledge FuseGI courses can give us. And moving on, a few words about the structure of the courses. First of all, we have the introduction in GIS, application and uses. Then we move on to the mean of spatial data, vector versus raster models. And then in the 3rd lesson, we have the installation of QGIS step by step, as I have already said. And then from the 4th lesson and 5th lesson and the 6th lesson, etc., we move to practical advices and tool analysis of the software. So each course comes with the supplementary material, the necessary tests. So it contains a secondary file which has open books, articles, and other open courses. Everything was found open and free on the net, and all authors are referenced. So the result. Our goal was overachieved. There is a curricula ready for adoption, a VLE platform ready with the right material and the whole courses. There is more than a platform, but a self-tutoring tool for scholars, businesses, free from rights and easy accessible. This is how our project ended. If you want to find it, you can just Google FuseGI and the word VLE, and with a quick login, your name and your email, you can attend our courses and find all the material that is there. Thank you very much.
Thank you very much for this very compact interesting presentation. I guess we'll have time later to discuss some of the project. And now we move on to the next presentation by Dr. Petra Zupanova about verification 2020 geomagnetic models over the Bulgarian territory.
Hello?
Welcome.
Can you hear me? Yeah, I will start sharing my screen. Is it okay?
Yes.
Okay, hello everybody. My name is Petra Trifonova, and I'm working in the National Institute of Geophysics, Geology and Geography of the Bulgarian Academy of Sciences. I will present you research which is elaborated with Dr. Metodiev, who is my colleague from the Geomagnetic Survey Group in our institute. My talk is connected with the verification of two geomagnetic models for 2020, which are covering the territory of Bulgaria. As you heard in the previous presenters, there are a lot of models, and they are like playing with numbers and images, etc. But it is very important to see and to check how accurate are those models, and that is the topic of my talk. Here is a brief outline of my presentation. I will tell you some words about the geomagnetic field and the geomagnetic models. Will explain you how geomagnetic data are obtained in Bulgaria and what models exist. And of course, I will show you the results of our work. Now, what is the geomagnetic field? The intensity of the geomagnetic field ranges from 25 microtesla near to the equator up to 65 microtesla near the Earth poles. In Bulgaria, in Balkan Peninsula, we have values about 47 microtesla or 47,000 nanotesla, which is the unit which is used in the geomagnetic observatory practice. Earth's magnetic field consists of the magnetic signals coming from several sources. On this slide, you can see the list of those sources. The main part of the field is similar to the field which is generated from a bar magnet placed at the middle of the Earth's core. It is mostly caused by electric currents in the liquid outer core of our planet. And the first two components, which represents about 95% of the field, are varying very slowly in time, but are stable in space. Their changes are called annual or secular changes. And because of them, we need to update our models in certain period of times. The third component, the geomagnetic field, represents different magnetization of rocks. And it is changing not only in time, but also in space. The fourth component is changing quickly in time and space, and it is caused by the solar activity. So, if somebody needs to know the value of the magnetic field for a particular time and place, he will need to have up-to-date information about it. And who are the users of such information? Besides the science, which is connected with the problems of the field generation and the geomagnetic field evolution, the information about the Earth's magnetic field is used primarily for navigation. Now we have modern satellite navigations, and we have gyroscope systems in the ships and in the airplanes. But all of those vehicles needs to have a backup compass navigation systems, which they are obliged to calibrate and test periodically. Maybe all of you know that the magnetic field is a vector field. It has a magnitude as well as a direction. Here you can see the elements of the magnetic field. This important element used for navigation is namely the declination. which is the angle between the horizontal plane of the magnetic north, this direction, and this is the direction of the compass, and the true north, which is the direction to the real geographic North Pole. So this angle is called declination. Looking at the compass, I will recall you to the logo of our main conference organizer. This one. It looks a lot like a compass. And let's see, and the logo of NATO itself. There is the same arrows of the compass, and this is not accidental, because the magnetic declination was and still is an important part of the military services, and particularly for the navigation and orientation of the artillery weapon system. This is just to show you how important it is to know the accurate value of the magnetic field at every place and every moment. Here you can see one of the global declination models. Those models are prepared using satellite data, combined with data from ground-based geomagnetic observatories. This is a model of declination. The blue values represent negative angles, which means the compass pointing to the west. And the red values show positive angles. The compass arrow are pointing to the east. And here, from this model, you can see that Bulgaria is somewhere here, that the declination in our territories is around 5 degrees east. As I said, geomagnetic field is a function of both space and time. The internal part of the field changes smoothly over time, with periods of tens, hundreds, and thousands of years. And this change at different points of the Earth's surface is different, of course. For short periods of time, 1 or 2 years, however, it can be considered equal for territories with the size of Bulgaria. However, its change in space from point to point on the Earth's surface at a given moment can be very abrupt. And sometimes, for different practical purposes, it is necessary to produce map with the space variation of the geomagnetic field, and especially with the declination. The best solution for this would be to perform field measurements for a short time and to compile a map with real space values of the field, but unfortunately this is almost impossible due to the complicated organization and time-consuming procedure of the geomagnetic vector measurements. And what is the solution of those problems? Usually it consists of a combination of several tools. First one is the geomagnetic model. The second one is the so-called repeat station network, and of course the geomagnetic observatory. Geomagnetic models are obtained from using different calculation procedures. To prepare a model, you need to have real observations and to know some mathematical rules and techniques, and to express the main part of the field as a function of geographic coordinates. Usually, global models give only the core field generated deep inside the Earth. To obtain a good spatial resolution, however, one needs to have measurements in a denser grid and so-called secular or repeat station network. Here you can see the repeat station network of Bulgaria. It consists of 27 repeat stations and 1 geomagnetic observatory, which is located here in the town of Panguriște. Such observatories are very special facilities which are recording geomagnetic variations day and night, doing measurements twice per second. Repeat stations are stabilized points which are uniformly distributed over the territory of the country. And it is supposed that there will be performed measurements every 3 or 5 years. Unfortunately, this depends a lot, of course, of the budget which is available in a certain moment. Now I will tell you what models exist for Bulgaria and why we performed this study. I told you, and probably you are familiar with, if you have real measurements, it doesn't matter how old are they. And if you are familiar with mathematics, you can do different types of models, playing with numbers and images, and you can display whatever you want. But it is very, very important to check if the model is correct. In Bulgaria, we have geomagnetic models from 1960, which are updated almost every 5 years. Here you can see declination, horizontal intensity, and the total intensity of the geomagnetic field as a function of the geographical coordinates of the observational points. This is a model which is compiled 5 years ago for 2015.0 epoch. What means 2000.0? It means that the value which are displayed is the same as it would be measured on the 1st of January 2015. Each geomagnetic measurements must have such a date stamp because, as I told you, the field changes every day, every month, and every year. And we need to know for what exactly time are the value of our model. Here, in this model, the magnetic field value are approximated with the second-degree polynomial function of the geographic coordinates of the observational point. The next model, which we have prepared for 2020 epoch, includes the main field value as well as the crystal component produced by the rock magnetization. You can see on these maps that in addition to the general trend which we saw in the previous slide, there are some regions with a smaller scale variation of the components. These local changes are due to the influence of the rocks which have increased magnetic composition and which make the model more comprehensive than the previous model. But looking at those colorful pictures, we should not forget that they are results of old measurements and mathematics. How real are they? We didn't know and decided to check because we had the possibility to obtain real data measurements. In 2018, started the field campaign for a new magnetic measurements of the entire territory of Bulgaria. It is performed by the Military Topographic Service of the Ministry of Defense in cooperation with us, the Geomagnetic Survey of the Institute of Geophysics. A couple of words about the measurements. Bulgarian territory was divided into 4 regions: Northwest, Northeast, Southwest, and Southeast. Each year, one of those regions had to be completed with about 100 measured points. Each measurement continues at least 2 days and is performed by 3 persons, 2 for the geophysical measurements and 1 for the geodetic provision of the point. Next to the field card of the measurement, which is here on the left, you can see the equipment which is needed to perform a measurement. But this picture is from an empty airport site. In the field measurements on the entire territory of Bulgaria, usually the points are located inside forest or in difficult agricultural terrains, which make the measurements far more complicated. At one point, we must have at least 2 measurements made by 2 two different persons. So you can imagine how many people and how much time is spent for such a measurement. After the field campaign is finished, all these cards written during the measurement need to be processed. We are doing this using the field recordings from Panagiotis Observatory. And as a result, we obtain the geomagnetic field components at every point. In this research, we have 185 points, which covers the northern part of Bulgaria. This was measured in 2018 and 2019. As a verification, we compared two models, one global and one regional. The global model was the International Geomagnetic Reference Field with its last 13 modification. And the regional model was, of course, our model, which was compiled 2 years ago. And until now, it's used for updating the topographic maps. And what are the results? Results are displayed in these 3 panel pictures, starting from the top with the real measurements. They are here. In the middle is the regional model, and bottom panel is the global International Geomagnetic Reference Field model. Here you see the results from the declination. As I already mentioned, the global models take into account only the main magnetic field, this one which is generated deep inside the Earth, and cannot capture local inhomogeneities caused by the magnetization of rocks. And here in the bottom picture, you can see how smooth and stable is the trend of the global model, which is not the same in the other picture. Looking at the values in the 2 models values, we were very happy to see that we captured the range of variation of declination. It starts from 310 minutes up to 380 minutes. It is the same for the real measurements, regional and the global model. The good one in this regional model are these local variabilities, which are very similar to the real measurements, which means that this model is representing more comprehensively, more details of the real geomagnetic field. Let's look at the horizontal intensity. Again, we have very accurate match of the values, and here we have acceptable representation of the pattern from both models, and this is due to the lower variability of this magnetic field component. And the last picture, which I will show, is the total intensity. What we have here, we have similar results as for the declination. We have a nice global model, which is with accurate numbers, but don't account for the local pattern variability, which is seen in the real measurements and the regional model. There are, of course, some differences. The model do not coincide exactly with the real measurements, but the differences between them is acceptable enough. And now some words as a conclusion. It is indisputable that the real measurements are more accurate than the models, but here we proved that the models are reliable enough to be used for updating the maps. Regional models give more detailed picture of the geomagnetic field, but in case we don't have regional models, the global one are good enough to provide information with the exact values, with accurate values of the field when it's necessary to be used. The maintenance of the secular network and the periodic measurements are very important. You saw that it is important also for not only for the science, but also for the military purposes. And the last one, but very important, is that in Bulgaria we have accurate geomagnetic data and good practices for geomagnetic measurements. And that's all for me. Thank you for all your attention.
Thank you so much, Dr. Ivanova and Claudia, for presenting this great project. We move on to the next presentation by Dr. Nina Brinkova. It's about the Bulgarian platform for natural hazards data collection and decision support in field of labor.
Good afternoon, everybody. I hope you hear me well.
Yes, thank you.
Perfect. Can you see my slide? Did it start sharing?
Yes, it works, thank you.
Perfect. Okay. So today I'm going to talk about platform which we started 2017 in the 2017 to work on a project called eOutland. And actually that platform was not initially planned to be final result of this project. However, at that time, the volunteer groups and the civil protection and firefighting brigades who contacted us from Svilengrad, Topolgrad, Zlatograd, and Kresna didn't have enough data. That's why we had to collect data for them and work with them on the field, and we saw a lot of gaps in this direction. So I will give you an overview what we came in the end as an idea and what is actually the final result of this project eOutland. eOutland resulted actually in this risk map platform, which I will show you the stages how we gave birth to this platform. So our first steps when we started the project with our target groups was to look into the Inspired Geo portal, which in Bulgaria for operational data, most of the time is having that you have nothing to download or there are no results. So when you have to work on the field, it really, when it comes to forest fire or flood event, you need specific information in order to do your decision making fast, reliable, and accurate. Having this Geo portal not providing this operational data was our first big challenge. So that was what we saw in 2017, and nowadays it's actually the same. Last night I checked again this Geo portal, and it's absolutely nothing changed. In 2017, there were a lot of forest fires in Bulgaria, and the fire brigades and the civil protection authority were having most of the time this kind of lessons learned, which was something after the fire has already done its casualties or damages. That is why they put this on our Ministry of Interior as lessons learned, but no data is associated with this kind of outcomes. The same we saw for flood events, which were very big ones in 2014, and a lot of southeast part of Bulgaria was suffering at that time from those flood events. So we ended up in 2017 and 18 when we did with my team the initial research that data for hazards like forest fires or flood events are only available in text formats like alerts on the Ministry of Interior website, but nothing else. That is why we started slowly to collect from different projects which we were having in parallel running from different programs actually, to gather this into one database, and this resulted into this year risk map platform. But I will show you the other projects too in order to see how we collected what we have in our platform at the moment. So for the wildfire part, we had to start with the digital elevation model, with the fuel types and the meteorological data. And all of the three components actually are not freely available anywhere. That is why from the first project which I was working on, where the war fire simulator was applied for first time in Bulgaria in Harmanli area, we used a specific tool to collect information on the field, and we started actually with paper maps because there were no digital information for this area in this forestry department. That's why we digitalized the paper map and we started our simulations. So you can see how we have our own digital elevation model with the simulations which we did. And here you can see even the fire spread and meteorological vertices which the fire is doing itself when it is burning. So this is the first project we collected information from in order to do a lot of data collection for our platform. So this simulation results actually was our first step. Then again, my team was doing some simulations for forest fires, but this time in the Zlatograd forestry area, which covers 3 municipalities, which are Zlatograd, Madan, and Nidelino. And for those 15 fires, we managed to collect a full forestry department coverage with digital elevation model. These are the fires which we were interested in, but along with those fires, we collected the paper maps again with information about the land use and land cover. On the left side, you can see what we were having digitalized with images underneath in order to have better visualization. So these are all the 15 fires, and that was actually what we collected for the whole forestry department. Again, we used the Farsight model to do our simulations in order to add more information on that what we have digitalized. And here you can see our initial parameters for the Farsight simulation. That was again done for first time in Bulgaria, and the fuel model representative which we use here was for the grass, and then we elaborate that one into the Farsight simulator on the right hand side, the green cells. The same was also done for standard fuel models, because the fuel models for the forest fires are 52 to 53 worldwide, and we try to adapt what is available, what can be available actually for Bulgaria after calibration, or if we have to go for custom fuel models. And from this project and research in Zlatograd area, we came up with, this is the simulator. With the simulation, we came up with this table where you can see the models based on our research so far, what can be used for fire simulations. After that, this was actually done in parallel with the 2017 project of EOUT1 zone. There was in 2017 the Kresna fire, which was the biggest in the last 5 years in Bulgaria, and it actually covered 3,200 hectares, which is huge area for Bulgaria fire. Again, we started collecting data from the forestry department for the digital elevation, from the land use, land cover, all the images which we could find from drones or whatever lower flying machines in order to have better visualization. So again, we use the table with the models and we calibrated what we had so far. And this is how the fire looked like after our simulation, which was a really good match compared with the other 16 fires which we already have done. So this was the best, and our calibration with the models was going very well. Yeah, this is the time of arrival of the fire, which corresponds with the real data collected from the field. Then our foresters and firefighters actually told us that after forest fires, a lot of flood events, especially in the Svilengrad area, were occurring along River Marica and its tributaries. And at that time, my team was working on a project called Alter with the Ministry of Interior in Armenia, where we adopted a really nice algorithm how a flood event can be modeled without using the commercial softwares. However, we had 1 year between 2018 and 2019 research in order to see which models are the best for Armenian test cases and also for Svilengrad, because Svilengrad was the test case in Bulgaria. So the one-dimensional, two-dimensional modeling options were compared, and then we did algorithm how a simulation has to be done for Bulgaria and for Armenia at that time. So the hydrometeorological observation data was very important for the floods. Air temperature, precipitation, evaporation, river flow characteristics for the discharge levels. These are very important. And especially having in mind that Marica is going after Bulgarian border, and it is like Danube between Bulgaria and Romania, but for Greece and Turkey, we had to be very precise in what we are doing. So that's why the elevation model had to be at least 30 meter from the global dam or lower. Then the digital elevation model, the geomorphology with its slope aspect, the hillside, and the hydrology with the flow direction, the stream definition of the segment, the catchment area, and the drainage was collected for the Svilengrad area. The satellite images were also done for Armenia and Svilengrad in parallel. And the land cover was done in this format. Other spatial data sets were available for Armenia, however, for us was not that easy, so we didn't have this extra data set. The survey data, which was something what we did on the field with our local partners in Svilengrad municipality, was to collect actually the cross sections of the river Marica plus its tributaries in the areas where flood events were very obvious that can happen. And in the end, we had to calculate also the flood hazard index for the flood hazard zones in order to see if the dikes which we had in Bulgaria are high enough in order to protect the populated zones, because Svilengrad is located on the river bench, and it's very easy, 2/3 of Svilengrad to be underwater when flood events occur in this zone. So this is how it looks like. Again, in Bulgaria, we had to start with the paper maps because digital information, like we said in the beginning from the Inspire Geo portal, is really not working. This is what we got when we were working with Svilengrad municipal authorities. Maps with different scales, but all of them paper. on the paper. So we had a good half a year to do digitalization of what we got on paper. Then we got the information about the dikes, which was very important for the calculation of the hazard index. And then we started with the data which we collected based on the algorithm that we created in Armenia. So for the 1,000 years wave, we calculated the red zones, which are definitely higher than 2 meters. This is the worst wave which Maritza could do. That's why the 1,000 it's something what the dikes was calculated for. Then the 100 years is again not good for the city center. If you can see, I have a better slide with more zoom on it. But you can see that the city of Svilengrad is most of the time in the red zone because Maritza in this area is really going with high waves. Also in real time, when we collected information from past events, we saw that Svilengrad is quite often underwater. The 5 years wave was also a good one because not so much of Svilengrad, at least the upper part of the city was underwater, but the lower parts, Gelemenovo, was always underwater. So you can see that in the red zones. So here it is the 1,000 years wave. You can see that Svilengrad on both sides is pretty much red. And that was something what the mayor was not happy to see. But he agreed that the dikes in these zones has to be better evaluated and most probably made higher. Also, you can see that in the middle of the river there are islands due to the sediments which are bringing the river of Maritza. So that was something what the mayor also cleaned after our calculations here. This is the 100 years wave. Again, on your right or left side, I don't know, is half of the picture. You can see this is the lower part of Svilengrad Gelemenovo. So that part of Svilengrad is always underwater, no matter of the wave which we calculated. This is the 5 years wave. And so that information was very useful for the mayor. And after that, together with him, we created this map where the buffer zones, where dikes can be broken in order to diminish the float event in the city area. Was suggested, of course, and that was something what they had to do in their crisis management plans. However, having these projects so far, we could collect a lot of information. And here, for the dikes in Svilengrad zone, we marked in red which dikes are lower than what we have calculated as high waves. So the mayor of Svilengrad, after our calculations, created higher dikes in the red zones, which we have calculated for them. And now the dikes in Svilengrad are higher and some of the islands in the river are gone. But during this period between 2017 and nowadays, E-Out1 project was still active, and my team was working all of the time with our firefighters, volunteer groups, foresters on the field in these municipalities. That's why in the end we suggested to our Greece Bulgaria officer to give us the opportunity to collect all of that information from the other projects which are already paid from different EU funds, just to have all into one pilot platform, which we called RiskMap BG, where we started putting all of that information into municipal areas or forestry departments. And that's why when you enter to the platform, you can select if you want to see what is in the municipal zone or outside the municipal zone where the forestry area is. So based on the projects we had so far, we have 5 zones for Zlatograd, Kresna, Svilengrad, Topolgrad, and Haskov zone. And these are actually the municipalities. And then when you go to the municipality, because it's really hard to get information from the National Meteorology and Hydrology Institute of Bulgaria, we decided to incorporate Meteo Blue Radar, which is giving in real time at least the wind, the temperature, and specific information which firefighters need for the precipitation and the radiation. Meanwhile, our officer of the Outbound project, she was really good to us. She's located in Thessaloniki. She gave us the option even to buy our own meteorological stations, which we located in Kresna, Zlatograd, Topolgrad, and Svilengrad, in order to have some ground observations, not only the Meteo Blue Radar calculations, in order to give the local fire brigade their own data set with which they could compare what they see from the radars and what they have from the meteorological station. That is why we created that information available on the website. But at some point, we had to divide the information which we are providing to the public and to registered users. Because some people start to panic if they see too high rainfall or higher temperatures. That's why we divided our software, and we used another 2 projects which we were running between 2018 and 2020 for the better visualization of what we had in our 5 municipalities. So here you can see the digital elevation area for Svilengrad, which is on the risk map. But again, like I said, we decided after that visualization to do division between the operational teams and the general public. That's why we started to divide the general information for the zoom, pan, scan, scale management, attribute search, and other information which comes from the GIS to be in the web module available for everybody. And we use that one from our project Landslide, which we use in Smolen zone. We also took from Landslide the layer visibility and the labeling also as already ready to use web module. Everything is open source in our tools. That's why we can easily extract from project to project different modules and incorporate them into the others, adapting to the local zone. And this functionality we left for the registered users, but for some of the features, we used another project which was done for Sofia municipality in order to have better signal collection from the field, because when we did our first test last year with our platform, it was not very easy to our end users, the firefighters and the foresters on the field to send information, because in the border zones, the internet coverage is not that good. And those guys were actually forced to use their cell phones in order to use the software. And that was not operationally good. But we try to solve that problem, and I believe this year with the tests we will do it better. So that's why we use that module from the GHOST project from Sofia municipality in order to collect and have everything into one console, which is available in the municipal operational room. And actually one operator who is having the general view, what is going on the field, is having everything centralized to his computer, and then the rest are just sending information to the operational room through either cell phone or tablets. And we are still running our tests because this system, as I said, was not initially planned under the eOut1 project. However, from the tests since last autumn, we have the ambition actually to capitalize on all of the past projects which we were running from 2015 up until now, and create useful a system with datasets that are already paid by other projects, but incorporated into the risk map platform and made available for those 5 zones where all of the test areas so far under my team have been elaborated. The platform, like I said, is done with open source tools and is hosted on a server, dedicated server in my institute, the Institute of Information and Communication Technologies in Bulgarian Academy of Sciences. So for now, we still have the eOut1 project running up until 2nd of December this year, but after that project ends, I hope we could still support and maintain that platform. And our target group is actually those guys from the firefighting brigades and the volunteers who are associated to them, and the forestry people. We were lucky with the 5 municipal administration people who also supported us a lot and gave us full access to everything they got as paper maps in order to get digital information for the projects we were running with them. I have to say that we are very thankful to our eOut1 project that they gave us the opportunity to capitalize on what we had as data, different segments data from different projects so far. And actually this risk map platform is going to be one of the major results of the eOut1 project. Thank you for your attention. If you have any questions, I'm here.
Thank you very much, Professor Brinkova. That's a great project. Learning exchange between Greece and Bulgaria, and we are, as ever, very grateful for your support to the center to invest in we. We can move to the next presentation. Mr. Nikolov will be presenting on behalf of the group, Dr. Milan Afanasov and Ivan Georgiev. The topic is creation of time series from SAR data for landslide investigation. Welcome. This is a online presentation, and Mr. Nikolov, you're welcome to part of this presentation.
Hello, dear colleagues. Can you see my presentation in a PowerPoint?
Yes.
Okay, thank you. I will start right now. Can you see it other whole slides? Okay, that's perfect. That's perfect.
Go ahead.
I'm just starting. So this is a mutual presentation between 2 institutes of Bulgarian Academy of Sciences, namely the National Institute of Geophysics, Geology and Geography and Space Research and Technology Institute. So we started monitoring landslides in Bulgaria, firstly by GNSS tools, and then we decided that a new technology is already available. I mean, satellite technology to use synthetic aperture radar data. So we decided to take advantage of both technology and produce better information in sense that from GNSS measurement one can get very precise but very few points for a single area, while the synthetic aperture radar data are providing a larger coverage. So we decided to start a project which is currently financed by National Science Fund, and so we could start our specific and dedicated field measurements. Other goal of our approach is to take advantage of the freely available Sentinel-1 data, which is crucial for us because if this source were not available, it could be almost impossible to have these results you'll see in the presentation. On the other hand, we also like to develop national level knowledge about how to process radar data. So we may say currently that we are at a good point right now. So a few words about the area we studied for several years. On the left side, you see a picture with some landslides set in the study area of Dolgia Yar, which is located between Golden Sands and Kranevo village. On the right side, you see the damages that are caused by activation of landslides. And again, on the left side, you see that the area is quite specific in the sense that you have one big landslide, and due to external factors, I won't name any right now, you can see the development of smaller ones. So you cannot say that the whole area is having one and same behavior for this. So some words about how the synthetic aperture radar works. Actually, this is work of European Space Agency. They decided to build a radar satellite which is capable to provide data regardless of the weather conditions, which is of crucial importance and serious advantage compared to optical data. Actually, the goal of the Sentinel-1 mission is to study surface displacement at regional scale, at least. And this is why two satellites were needed, and the Sentinel-1 is actually a constellation of two satellites. On the left lower corner, you see how the radar data looks at the moment they were acquired. On the right side, you see that you can get data from the satellite from two types of orbits, which are quasi-polar orbits. You see the small declination from the real node, denoted here with the arrow flight. And on the other hand, you see the look at the radar. It is a good point to say that the radar is acquiring data only at the right side of the satellite. So from ascending and descending orbits, you can form something like a stereo of the area you imaged. Here we provide a better picture for the acquisition of the radar data. Actually, in order to obtain useful information, you need data from at least two acquisitions at different times. So when you image the same area denoted by P here on the figure, from slightly two different positions, I mean in two different time frames, you can have you can judge if any surface movement have occurred between the two acquisitions. On the lower part of the slide, you see the time series we formed from the satellite acquisition between 2015-2020, and in order to study our area, we extracted only images from the, let's say, late autumn to early spring, because only from that period the information we produce from SAR processing can be considered as a reliable one. Other thing which is important when monitoring surface movements is to have this line between the two observation paths to be as minimal as possible. Ideally, it should be 0, but that's not easily achievable. Let's say even impossible in some cases. So we started with taking data from a single orbit, because we couldn't use the ascending path because of the specific orientation of the area, and some of the data were in so-called radar shadow, so it was not possible to use them. Here is the time series of the pairs we used to produce the interferometric images, which are the main source of information for the ground motions. And one can see that for this 6-year period, we produced about 30 interferometric images. On these slides, one may see the interferometric pair as they are formed. Also important here is to notice that the perpendicular lines, which need to be kept as low as possible, is not always in their good condition. Sorry. But we had to cover any single period we decided to examine. On the other hand, one may see that so-called model coherence, which is a measure of quality of the interferometric images, is quite high for all of them. I may say that for all of them, we selected data pairs that allow to have moderate coherence more than 0.09, which is quite high for us. Other thing to notice is that we had to select interferometric pairs that almost overlap, but the time period between the two is not always constant, as seen in the tables provided here. So I will move to the results we got. Here is excerpt of the interferometric image we produced, and this is just an example what one can get for the area. And on the lower right, you see the produced movements after the whole processing of the SAR pair, and enlarged for the area we studied. Here, I will continue with the results. You see on the lower part of the slide the time period covered and the displacements. It is not surprising that we are getting only for few areas which are not equal for all the interferometric images. It is not surprising that we are having so little reliable information, because because as you see from the background, the area is highly vegetated, which is one of the disturbing factors for interferometric processing and in interferogram production. Here, you see the next two periods. Just to draw your attention on the fact that we are sticking firmly to the, let's say, semi-winter period, or this 5 or 6 months when we are sure to get reliable information. We decided to stick with one and the same scale in order to make a fair comparison between the interferometric images. I'll go back a little bit for a while, just to draw your attention that what we produce from interferometric processing is not constant. You see that some parts are painted in different colors, which is due to the produced result from the interferometric processing. On all those images, we show the dedicated local geodetic network we measured in 3 cycles up to now, and next month we are going to measure the 4th cycle, which will provide a better picture on the ongoing movements in situ. Just for a completion, you may see that for the period 30th of October 2020 to 10th of April 2021, the movements are only 2 centimeters, while for the previous period they are a little bit larger. But just to say that these displacements are not recorded as direct 3-dimensional vector and its vertical component, but they are in line of sight of the satellite. So in order to produce this 3-dimensional vector, some sophisticated processing is needed, which is not made currently by us. I'm going a little bit further in order to show you the type of in situ information we used in our project. On the upper left, you see the continuously operating receiving station of the geodetic network maintained by National Institute of Geophysics, Geology, and Geography. And on the lower right, you see again the dedicated geodetic network we created for this project. As I already mentioned, we have 3 cycles up to now. We may say that the information we obtain in situ is of high quality because we used modern GPS receivers with good precision of 2.5 millimeters in horizontal plane and 3.5 millimeters in vertical plane. Here shown is the table with the results we have from the 3 measurement cycles. You see the north component, the east component, the vertical component, and the displacement in northeast plane. Since this slide is not easily readable, here I provide a summary of the table. You see that in the two cycles we have already the movements are not equal, which suggests that the landslides are not constantly moving, but are activated by external factors, as I already said. Other interesting thing we should notice that the vertical component is also quite different for the two periods. And here I go to the conclusions we may draw from our research up to now. We introduced a method for detection of landslide, which is used technique taking advantages of two different type of data, satellite and in situ. From the in situ GNSS measurements, we produced the movements for this object located at the Black Sea coast. And the key, not the key point, but it needs to be underlined that without data from the permanent stations of the geodetic network of Bulgaria, it would be not possible. It would be not possible and not easy to process the data from the in situ measurements. Other point to highlight is that we produced a big time series of interferograms that showed the ground motions in line of satellite line of sight of the satellite. Implementing a so-called small baseline approach. And for this reason, we considered as a reliable only points having so-called coherence, which is above 0.3, which was applied for all scenes. And finally, I would like to conclude that from our research, we find a good correspondence between the in situ and the satellite data for this site. Here are the emails of the authors. And here I would like to thank you for your attention and to close my presentation.
Thank you so much, Paula, for your presentation. It seems we're ahead of schedule, so we'll skip the break. This is an ad change to the program. We'll move forward with the presentation and approach to forest fires in wildland urban interface areas. A case study from Greece. This is another very interesting topic that relates to the previous presentations. It's a joint presentation online by Mr. Konstantinos Liberopoulos and Professor Isaac Kaskaridis, and Mr. Liberopoulos will present on behalf of the
it's okay, the presentation. Do you see it?
I see your name, but
not the presentation.
No. Can you just try sharing your screen?
It's okay now?
Yes, it works. Thank you.
Good afternoon for me. I'm Officer 3 Konstantinos Liberopoulos, and it's my honor to be here to present my work in collaboration with Professor Particulate. I'm a PhD student at Hydrocarbons University, Department of Geography, and a member of Earth Observation Team of the university. My professor is the leader of the team, and as any summer, and this year, one more time, we're monitoring all major fires in Greece. My work is an approach to forest fires in wild and urban interface areas for case study from Greece. The forest fire is one of the three main hazards, including earthquakes and floods, which are threatening the Greek territory. This study makes a focus on the forest fires at the last decade in WE areas and trying to understand the reasons for the rise and to find a way to reduce the consequences. Furthermore, the study accomplishes statistical analysis of the WE land use from 2012 to 2018, the fire-related factors, and propose a method to define the most vulnerable settlements. So, the four key scientific questions which our study trying to answer are the following. First of all, what is the wild and urban interface area? Second, how this area is determined to the Greek terrain. After that, we are trying to find the relationships between WE areas and the last decade's fire in mainland Attica. And finally, and more important answer is the fourth question, to identify the location with the highest risk of fire at WE areas in mainland Attica. So, as we see, a wild and urban interface area is the area where built environment meets or mixed with a natural environment, and the settlements are at a greater risk of catastrophic wildfires. There are two basic categories as the photo. The intermix WE area where the forestry is mixed with houses, so the land use is mixed too. And the interface WE area where we have a clear border with settlements near forest land use. As we see, typical WEs are urban or rural areas, but WE areas can exist in a range of urban environment. So, as we find what is WE area, now we have to determine it to the Greek terrain. The Greek legislation does not specify the process to determine the WE areas, as well as their spatial boundaries, so we choose for the study the French legislation to do it. So according to the WE areas in the interface area with a buffer zone of 200 meters from an urban area, which at the same time includes the distance of at least 400 meters from fuel. Urban and fuel is determined as land uses of specific codes on corner land cover. So we use the corner land cover to calculate the urban and fuel layers. If we see more carefully the WE areas with this legislation, there are parts of them which are not contain fuels land use, and are less vulnerable to fires from other parts. So we see WE areas in green and WE areas in white. In the map. The study area is the bigger of the blue polygons we will see in the map, and is the mainland part of Attica region, which contains Athens, the capital of Greece, with a population of 3.1 million people. The data which used for the study appear in the slides. There are open data, and also there are data from the Hellenic cadastre. So, for the fire statistics, we use the available Copernicus high-resolution layers and especially recovered density and previous for the years 2012, 2015, and 18. As we see, the most major fires, the last 7 years contain WE areas, and all of the last year fires too, with no exception. All the fires in 2021 is in WE areas. For Attica only, some small fires didn't contain WE areas. And we have the fire of Mati as example. The most deadly fire event the last year at 2018. As we see, Mati was an intermix area with high 3D copper density, and we see the changes after the fire. Also with the use of the tree cover density layer and impressiveness. So these are the conclusions of the, especially for Attica, we can see for the last year's major fires that there is a big tendency of urbanization, as we see from number 16, number 22, and is indicative about the pressure of the city to Athens to become larger. So these are the conclusions of the statistical analysis. We will see it with the layers before. The final question was how can we identify the high risk locations in key areas of mainland Attica? So we create a model with 3 factors and 7 criteria. The first factor, it was derived spatial models contributing to the climate, such as aspect, slope, and elevation. The second factor, the land use with NDVI and Korean land cover criteria. And the third factor, socioeconomics with the distance of settlements and roads as criteria 2. The weights are determined using analytic hierarchy process, and the result is classified at a scale from 1 to 5. As we see from the workflow, we mix the criteria values with the formula of the slide and create a risk map. For the WE areas risk map, we clip the data from the previous map only for the WE areas, and with the resampling, we found the locations with highest risk values. This is the fire risk index map in mainland part of Attica with some polygons from past major fires. It's the first product. And this is the map which presents the fire risk index and the mixing zones and the 50 WE locations in Attica with a higher risk. As a result, we see the following. The areas with the highest values appear near the urban areas, where simultaneously there is a forest of areas less vegetation. There is a high risk of fire in areas with less vegetation in coastal areas of Attica, such as the east, south, and west coastal zones. There is a large risk of fire on hills or the foothills of the mountains in contact with the urban areas. And in the recently burned areas, the risk of fire in low but increasing significantly over the time. There is usually a high risk of fire around the burned areas where the fire was fire extinguished. So to the next slide, we have a validation for the model. For this summer, we already have 7 fires at Attica, all in WE areas. We have Kamatero and arson near a house. We see the fire from the security camera. Magula in industrial area. Schisto in a hill with a view near the houses. Panorama, a mountain with a view near the house in a very expensive neighborhood to have a property. Megara to an area near houses. Malakas, a try for arson, a forest near the major road. And Artemida, a very expensive seaside urban area. As we see to the map, the number 1, 3, 4, and 7 fires are in high price location with biggest number 4 in the most expensive. It was the biggest fire. The 6 was only a try for arson, and 2 and 5 is more industrial cities, but near the settlements. All the fires started in orange places near roads and settlements. And the biggest one, number 4, at the biggest one, the Copernicus Emergency Management Service activated. Here's the other map, which may explain why it didn't have human losses like Mati. No high-rise. We have no fires in the points we have. Very large risk. So, as a conclusion, the model has very good results about the starting points of the fire, but the burning area and the fire spreading is greatly influenced by the weather conditions. The case of arson will be taken into account in the future risk model. In addition to the distance from the streets and the settlements, the value of the real estate properties may have to be included as a variable too. And local authorities should consider the installation of monitoring, early warning system, and equipment of emergency firefighting around the high-risk settlements. Here about some of indicative bibliography, and I'm ready for your questions.
Thank you very much, Major Mavropoulos. I think we have plenty of time for questions, feedback, input. So we have a Q&A session on all the presentations. This will be a long session. We'll be happy to receive your feedback, criticism, questions, input. You can also use the chat to deliver questions. No questions. So it's been a long day. Thank you very much to organize the conference, Colin Yursky, Colin Androv, and Mrs. Pavlova.
Thank you very much, Professor Sirios, for being a moderator of this panel. And for today, we can close the session. It's a little bit before the scheduled time. So tomorrow we'll start again at 9 in the morning and with the panel Water Resources and Management. I think, sir, you are also the moderator for tomorrow topics, and it will be the shortest day because we would like to finalize the conference tomorrow around 11:30. Thank you very much one more time and have a good evening. Thanks a lot.